Hey, hello everyone, and welcome to React Best Practices. I am Andrew Ehrig with O'Reilly Media, and I will be your facilitator for the class. Our instructor for today's session is Sean Wassel. Sean is a lifelong programmer and problem-solving addict. His goal is to help people build incredible software and solve meaningful problems by mastering the art of software development. For the past 2 years, or over 2 years, he's been a trainer at CBT Nuggets and focuses on creating high-quality web development and certification content. You can check out his extensive collection of React, Angular, Python, and JavaScript courses, as well as a huge amount of other software and IT training content at cbtnuggets.com. So we're excited to have him back with us, but we do still have some quick housekeeping before we begin. We do have the attendee chat and the widget tray towards the bottom of your screen. So if you have a question or comment at any time, you can submit it there. If you have a specific question relating to the topic, we do encourage everyone to submit those through the Q&A widget. But I would like to remind everyone to refrain from putting any personal information into the chat, anything like your email address or phone number, just because that chat window will be included in the recording of this webinar. And that recording should post and become available about 24 to 48 hours after the live session ends. And a reminder for those of you who are subject to regulated status, chat features should not be used. The audience may include customers, vendors, or competitors of you or your employer. If you choose to take advantage of the interactive features available in this training, and we hope that you will, you are responsible for any information you choose to share. So without a further delay, I will now turn things over to Sean, and we can begin.
All right, thank you so much, Andrew, and welcome everyone to React Best Practices. We're going to be learning a lot of very interesting things today, and really what we're going to be taking a look at here is really just how to do React apps in the right way. And I think that many of you who work with React on a daily basis, as I do, are probably aware of the fact that it's perfectly possible to write a React app that works, but isn't very well written, right? It's not maintainable. It's not performant. It's not, it doesn't look very good. It's poorly organized. And that's the kind of thing that we're going to be addressing today, because the moral of the story is that React is just a very easy library to learn the basics of, but it's a very hard library to master. And really the amount that you practice it and the amount that you understand these best practices that we're going to be covering here, that's really going to determine how far you go in your career. It's as simple as that. So without further ado, let's get started. And I'm going to share the slides on my screen, mostly just because, I mean, they're up here and you can definitely download the PDF if you want to. But I'm going to be sharing them on my screen because I'm going to be doing a lot of demonstrations. And usually I just forget to, I almost always, in fact, forget to share my screen again when I'm bouncing back and forth between demonstrations and the slides. So let's just jump over to my screen share here, where you should be able to see my slides come up in just a minute here. And once I see those come up, we can get going. All right, cool. So let's just get started here by going over, I'm just going to give you a brief overview of what we're going to be covering here, just so that you know what to expect in the course and can kind of plan accordingly, I suppose. So the first thing that we're going to be talking about is best practices with regards to components, right? Because components have such a foundational role in React applications, it's really important that you understand some of the best practices around them and know how to, basically what to do and what not to do when working with these things. And I mean, especially now that React is kind of maturing as a library. I mean, I don't want to say that. It's definitely matured as a library, I would say, but because it's been around for quite a while and things have changed a lot, right? It started off, your components had to all be classes. Now you can write them as functions, and now there's hooks and all that kind of thing. So there's frankly, there's just a lot of old or bad code floating around in the React universe of code examples. And so it really is important that you understand what the best practices are, so that if you see someone doing something another way, you're like, oh yeah, okay, that works, but that's really, there's a better way to do it, and that's this. So that's going to be the goal with that section. The next section is where we're going to talk about some best practices with regards to project structure and organization. So the point of this section is going to be to kind of take a step up from looking at individual components and some of the best practices surrounding those, and actually taking a look at what some of the recommendations as far as organizing our entire React project are. And in many cases, I've worked with a fair number of different teams on different React projects over the past few years, and really I've been very surprised how just a few simple changes in how you organize your project structure can really make a big difference in how easy that project is to work on, and especially things like how easy it is to bring on new developers to your team, as well as things like build time, performance testing. There's lots of different things to keep in mind with those, but that's what we're going to be talking about in that section. And the third section is where we're going to be talking about some best practices with routing and navigation. Now, this one is, it's not quite as important as the first two. Really, we're going to be spending the majority of our time probably on the first two here. But, the best practices that we're going to be talking about with routing and navigation, obviously that's an important thing when you're first setting up your application, right? Getting that right at the very beginning, right? So that you know kind of how the routes of your application are going to be organized, and some of the best practices around that. That's just going to set you up for success once you see what some of those best practices are. Next section is where we're going to talk about performance optimization and some of the things we can do there. There will be a little bit of overlap between that and some of the first three chapters, but it's obviously something that's very important, and so I wanted to talk about it on its own. And the last section here that we're going to go through are some of the best practices with regards to security in React. Now, we'll talk about this in much more detail when we get there, but because React is a front-end library, really a lot of these security best practices are just things that you definitely shouldn't do in your React project. So you're definitely going to want to stick around for those in case you're not familiar with that kind of topic. So cool. These are what we're going to be covering today. Let's get started with the first section. Oh, and before we do, one thing that I wanted to mention, I'm glad I put this slide in here because I would almost always forget it if I didn't put it in here. As far as Q&A goes, especially in courses, it looks like we have quite a big course today. So in courses like this, it gets very easy, or it's very easy for the questions to get lost in the attendee chat. So if you have a question that you want me to answer, I definitely prefer it if you put it in the Q&A widget. It just really, it really helps me to keep all that stuff organized and make sure I'm answering the questions that I find relevant and in a timely manner. All right, cool. So anyway, now that we've got kind of the basic structure of our course, you know where to submit your questions. Oh, and the last thing I wanted to say about that is that usually what I'm going to do, just because once I get going on a topic, it's kind of hard to stop. I'm like a freight train in that way, I suppose. But usually what I'll do is I'll answer each question after the break. And that also gives me a little bit of time to research, research a question if I don't immediately know the answer to it during that break. So feel free to submit your questions whenever, but I'm going to be answering them after the following break. Cool. So let's get started here with section 1, component best practices. Really, this is, I wanted to put this one up at the front because really, I think that this is probably one of the more important groups of best practices in the in the React ecosystem. So let's just go over what we're going to be talking about here, just so you have a kind of an overview of what to expect. The first thing we're going to be talking about is smart versus dumb components. Now, this is something that you may have heard about before, and the fact is that a lot of these, a lot of these terms, right? A lot of the vocabulary that I'm going to be using in these best practices is probably things that you've heard before. I mean, if any of you work with React on a daily basis, as I imagine many of you do, the fact is that there's just a lot of terms that get thrown around, like smart and dumb components, for example, that people understand the basic concept, but they don't actually apply that in any meaningful way. So that's what I'm hoping to help you out with here in this course is, kind of understanding these concepts on a more practical level so that you can actually go and apply them in real life. Cool. So we're going to be talking about smart versus dumb components. We're going to be, after that, talking about functional components versus class components. This is still it's not really a debate anymore, I guess, but it's still something that people don't quite understand what the purpose or what the when you should use functional components or when you should use class components and what the difference is. And a lot of people think that class components just have no purpose whatsoever and wonder why the React team hasn't removed them. But that's kind of the thing that we're going to be talking about there is just how do we deal with these two different types of components, and are there any things, are there specific cases where functional or especially class components are going to be better or a better or worse choice? All right, so the next thing we're going to be talking about composition over inheritance. Again, this is probably stuff that you've heard mentioned before, but perhaps you've never seen it demonstrated, or perhaps you've seen it demonstrated just kind of in a very rudimentary way and don't actually know how to apply it to your projects. So don't automatically assume just because oh yeah, I've read about composition versus inheritance in React. Don't assume that you already know how to apply that. That's okay, right? We're going to be talking about that's the purpose of the course. I'm assuming that's why you're here. Cool. So composition versus inheritance. After that, we're going to be talking about best practices regarding prop types and default props. And then we're going to move on to looking at pure components and memoization as well, right? Pure components are just for class components. Memoization is just for function components. So we're going to be taking a look at best practices around those. Cool. So let's jump right in here. We'll start off with the basic discussion of smart versus dumb components. And really, it's you might hear different terms thrown around here. I don't mean any offense by smart versus dumb. Really, it's just it's how much thinking the component has to do, as you'll see, that classifies it as one of these. So let's start off with talking about smart components, because generally smart components, for people who haven't had the unfortunate experience of using too many smart components in a very complex React application, smart components are usually the kind of component that people write by default, right? So smart components basically are just components that have some sort of state or complex logic in them, right? So, if you have a component that's doing things like loading data, and maybe it's transforming that data in some way, and maybe it's doing some logic down in its JSX portion, right? The JSX that it's returning. All of that stuff qualifies a component as a smart component, right? So smart components, obviously, they're not a bad thing, but they're not necessarily a good thing either. And that's again, going back to the terminology of smart versus dumb. Dumb components aren't necessarily a bad thing, and smart components aren't necessarily a good thing. You just kind of want to have a good distribution of those. You want to have smart and dumb components in the right places in your application. So really, the main downside of smart components is that they're just less reusable, right? They're less reusable, and that's because they're implementing excuse me. That's because they're implementing some of the main business logic of your application. And by business logic, that's just kind of the things that your application was designed to do. So if you, let's say that you want to display certain, or let's say that you want to allow different filters or something like that to be applied to the product data that your application is going to be displaying. Let's say you're building an e-commerce application. That's going to be the business logic, some of the business logic in your application. And again, because that business logic is just inherently kind of complex, right? That's what your application is being designed to do. The components that contain it are inherently going to be less reusable. And I've definitely seen quite a few applications where you have two components that are kind of the same thing, but really what differentiates them is that business logic. And that is, by the way, something that you kind of want to avoid in many cases, is having components that are like that. We'll talk about that in more detail shortly. But anyway, that's the basic idea of smart components. Dumb components are really just components whose main focus is on the user interface and taking props and organizing them as part of that interface. So really, dumb components are just going to be completely, or at least mostly, devoid of things like state management, logic, data loading, any other data sources, etc. And because of this, they tend to be highly reusable, right? And this makes them ideal for really any kind of user interface element that is going to appear in many parts of your application. So we'll go through some examples of this, of course, but really what you want to do in your application is you, as I've already said, you kind of want to find that right balance between smart and dumb components. In other words, you don't want all of your components to be smart components, and it really just wouldn't be possible to have all your components be dumb components unless you're creating a very kind of boring static application. All right, so let's talk about when to use these things, because I think that that's the main source of confusion when it comes to smart versus dumb components. And then once we've gone through these things, I'll actually go over and we'll take a look at some code that demonstrates all of this. All right, so in case you're wondering what these things look like and you want to see a concrete example, we will get to that very shortly. So smart components, the main idea here, again, is that these components maximize your control over the application, right? So you can, in theory, put any logic, any business logic, especially any data loading that you want in these components, which gives you a very high degree of control, but at the same time makes these components very specific. So let's say that you have a component whose job is to load all of a user's friends, if you're building a social network, right? Well, in that case, that component, let's say that it does something else, like maybe it displays your top 10 friends or something like that. Well, that's going to be pretty specific functionality, right? And again, if you want that functionality in your application, you're going to have that logic somewhere. There's just no way around it. But maybe you don't want to add that into a frequently reused component across many different pages of your application. So again, state management, anytime you need to do any kind of state management, especially complex state management, this is going to be in a smart component. So let's say, again, this is the example that I used earlier. Let's say that you have a component whose main job isn't to display a list necessarily, but is to actually filter some sort of content on your site, right? Maybe you're filtering products or something like that. Well, all of the little filter options that you give, if you can picture this along the top, I unfortunately don't have my Wacom tablet here. I moved that to another location, so I unfortunately can't draw this out with that. But picture here that we have a search bar, and then under that you have a lot of different little filter buttons and options. Well, which ones of those are actually selected are going to be, most of the time, there are other options for this, of course, but they're most of the time going to be stored in some sort of state. So that's an example of an application for a smart component. Data fetching, of course, is another one, and a good example of this would be something like a higher up page component. And that's another thing that we'll mention here as well in a minute or two, is that smart components tend to be the higher up components in the application. So if you have a lot of different pages in your application and each page has specific data needs, it's usually going to be the page itself, if you follow the best practices, it's usually going to be the page itself that does that data fetching versus the lower down components where that data is actually displayed. All right. So that's another thing that smart components usually will do. Data distribution. This one's kind of interesting because in many cases, the data that you load from the server might be just a lot more data than you actually than any one component will need, right? So you might have a page that needs to display, let's say, a bunch of products. Maybe it also displays the user's shopping cart. Maybe it displays the user's previous purchases. Maybe it displays other items that the user might be interested in. That's a lot of data, and you're not going to be displaying all of that data in the same component. So sometimes what you'll do is have a data distribution component that doesn't actually take care of the loading of the component necessarily, but its main purpose is to take that data and actually put it where it needs to go in its child components. That's a possibility. Some people prefer to just do things some people prefer to just have their data fetching component also distribute the data. There are obviously pros and cons of each, but we'll talk about that in a little while as well. Cool. So those are some of the main times that you'll want to use smart components. Is whenever you have any needs with state management, data fetching, data distribution, things like that. So dumb components, as we've already said, these maximize reusability. And actually a question that I just saw show up in the Q&A widget, which is a very good question, is by reusability of smart and dumb components, do you mean reusability across a single app or across multiple apps? Well, that kind of actually amplifies what I'm saying here, because the fact is that I was only thinking of reusing these components across a single application. But the fact is that, if the company that you're working for, let's say, has multiple different applications that all share a common interface theme, right? So I'm thinking of things like the Google Suite, right? G Suite, all of those different things like Google Drive, Gmail, Google Hangouts, all of those things there. Is it even Hangouts anymore? Or is it just, did they just call it Google Voice Call? I don't remember. But anyway, if you're working on sort of a multi-application like that, then this becomes even more important, because you might, by having dumb components or by having business logic in one component in one application, you're really making it so that you can't take that component and use it in another application, because those are two completely separate applications with different business logic. However, by creating these dumb components, right? Let's say that you create a list component or a button component, and really these could be as simple as just basic user interface elements, right? So if you have a button that's just a floating button down in the bottom right corner, as Google, all of Google's apps were doing for a little while, then that would be a great example of a dumb component, right? It doesn't have any business logic, doesn't do any data fetching. Maybe it has an action that you can pass to it, but the component itself isn't actually responsible for performing that action. All right, so a few things that you might see dumb components used for are, obviously any kind of presentational purposes. So if you had a user list item component, let's say that you're building, again, a social network, and there's lots of different contexts where you want to display some sort of list of users or lists of friends, having a separate user list item component that doesn't have any of its own logic or any of its own state, business logic, data fetching, etc., is going to be, it's just going to make your life a lot easier, because you're going to be able to reuse that across potentially all of the different lists of your application. And that actually becomes kind of an interesting little challenge, is making it so that you can use just a handful of dumb components across a very wide range of different situations in your app. So just as an example of this, we might have this list filter component, and this list filter component might somewhere down the line display a user list item component, right? But then you might have another component that doesn't have any filtering capabilities, and that might also use this same user list item component. Whereas if that user list item component were to have its own logic, and maybe if it were to fetch its own data, let's say, um, that you'd only be able to use that in a single place, or maybe in 2 or 3 places if they happened to all share the same functionality and needs. All right, so obviously for presentational purposes, dumb components are just going to be, well, no pun intended, a no-brainer. But also for any kind of reusable atomic, we'll call them UI elements, right? So for buttons, text inputs, any kind of special UI element that your application is going to have in many different places, that's going to be a great application for dumb components. And also if you're creating some kind of if you're creating some kind of user interface library of your own, right? So if you're doing something like there's React libraries for things like Bootstrap, of course, and also for Google's Material UI. If you were going to do something like that for your own components, you definitely want all of those components to be dumb, because what good would a button that fetches a specific type of data be, in a reusable library? It just really wouldn't make any sense. Cool. So anyway, that's really the main topics, the main things I wanted to cover with smart versus dumb components. So let's jump in here and start taking a look at some code that will hopefully help us demonstrate these things. So what I'm going to do, I'm going to be using Visual Studio Code for this for these demonstrations. You can use whatever IDE you prefer, and I'm just gonna use Create React App in order to create a simple React app here. So I'm gonna imagine that you already know how to use Create React App. If not, just feel free to look it up. It's very, very easy. But anyway, let's get started here. I'm going to say npx create React app, and let's create this new React app called something like, we'll just call it best practices. All right. I already have a folder here called React best practices. I wasn't really thinking, but I guess I could just create it in here. Actually, I like that idea a little bit better. So we'll say npx create React app, and we'll create it right in here. Oops, there we go. And that should create our React app for us in here. So while that's running and installing and creating all its good files, let's talk about the example that we're going to be going through here, at least one example. We're going to be starting off by talking about a simple user info application, right? Let's just imagine that we're building some kind of social network, or maybe it's just a contact sharing application for your company, right? Something to help everybody figure out who's who in your company. Well, that application is probably going to need to have some sort of user info page, right? Where it displays, each user's name, maybe their email, maybe their interests, maybe a bio about them. And the way that you do this, of course, is going to make a big difference in how reusable that component is. So what we're going to do here, we're going to go into our source folder, and we'll create a new file here. And by the way, this is something that we'll talk about a little bit later. I'm just creating this new file inside the source directory. That's probably not something that you'll want to do if you plan on your project getting fairly large, just because it's obviously impossible to keep all your files organized if they're all in the source directory. So let's create a new file here, and we'll call this something like let's try that again, userinfo.js. And then what we're going to do is we're going to create another new file called something like user profile page.js. Cool. So right away, just by the names of these two things, which one do you think is going to be a dumb component, and which one do you think is going to be a smart component? Well, I'll tell you. The user profile page is probably going to be the smart component, and the user info is probably going to be the dumb component. Because think about this. Think about which one of these is going to be reused more often. It's probably not going to be the user profile page, since that represents an individual page in our application, and we're probably going to want there to only be one of those, right? obviously it's going to be loading a lot of different data depending on which user we're currently looking at, but that's ultimately going to be the less reusable one. Now, as far as user info, and I'm tired of not being able to draw here, so I'm just going to try and draw with my mouse. It's going to be a lot sloppier than when I was able to use a pen to draw these kinds of things. But what we're going to do is we're going to have just this reusable user info component that has like a user profile picture, perhaps. That's what that's supposed to be. I think that's not bad considering I'm drawing it with a computer mouse here. Then maybe it's got the user's name underneath it, an email, and maybe it's got a few lines for the user's bio. And maybe it's even got the other people, some of the other people, or maybe pictures of some of the other people. Those are supposed to be circles, by the way. Let me try that again. It's hard to draw a circle with a computer mouse. There we go. Maybe it's even got pictures of some of the other people that are on that person's team, right? So that you know who works together, something like that. All right, well, this here has the potential to be a very, very reusable, nice, wonderful, dumb component, right? It's going to be, and again, when I say dumb, I do not mean that in any kind of like bad way when we're talking about React components, because dumb components in many cases are far more reusable and have the potential to have far more far-reaching consequences than smart components, as you'll see. All right. So this here has the potential to be a very a very nice reusable component, but only if we're disciplined enough and only if we follow the best practices and keep any kind of complex logic or state or anything like that out of it. So this is the perfect example of what a dumb component can be. And the next question is, well, then how are we going to get all of this data in the first place? Well, generally what you're going to do, what I'm going to recommend you do is, and I'm just drawing a box around this component here. It's a pretty good box, considering I drew that with a computer mouse. It's not bad. But anyway, what you're probably going to want to do, of course, is have the user profile page be the one that is in charge of displaying this user info component, but also B, you're going to want this user profile page. Let me try writing user profile. We'll call it UPP for user profile page, and this is going to be the user info component. We're going to want the user profile page to do all of those business logic-y specific tasks like load data from the server. I'm just going to draw the server as a box here, and there we go. That's as close to a server icon as I'm going to get here. All right, so we're going to want the user profile page to do things like load data from the server. We're going to want it to do any kind of data preparation. So if that data isn't quite in the format we want it to be, right? Maybe it comes back as an indexed JavaScript object with all of the user's IDs or something like that. We're going to want our user profile page to be the one that will actually take care of all of that for us. And then once it's got it, this user profile page is actually going to be the one that will pass that data down to user info. Now, what this would allow us to do is, let's say that we wanted to display this user info component on multiple pages, right? It's a very reusable component after all. And another example of this would be, let's say that we want to have a page where you can view your own profile, right? Well, obviously that's going to have a very different set of needs than the user profile page, right? So in that case, what we might want to do is it'll have your user profile picture here. And then, of course, it'll be the same things underneath that. It'll have the people that you work with, right? And the way that we would get the different data in here is just by having a different page with different business logic that takes care of all of that stuff for you and passes it down to this user info component, right? Again, dumb component doesn't really need to do anything except take the data it's given and display it in a very nice and attractive way. So that's the basic idea here, is that, again, dumb components can be reused in a wide variety of situations, but usually somewhere higher up in the tree, they're going to depend on a smart component to actually take care of all of the logic, all of the planning and organization that is for them. So let's just take a look and see what this would look like in the context of our application here. Let's start off by creating our DOM component, because those are usually a little bit easier to to create and to understand. But anyway, let's get started here by creating our component. And this is just going to be a function component. There obviously is another option of doing class components. We'll talk about that distinction a little bit later on. But we're going to say const user info equals, and then let's think about the kind of info that this user info component is going to need to take. Well, probably what we're going to want to do is just allow ourselves to pass that user info object, or whatever it is. Oops, I had a cord stuck under my escape key. I usually use the Vim plugin in Visual Studio Code to navigate around. So the escape key is kind of important for that. But anyway, we have const user info equals user, and now we can just kind of choose what we want to do, how we want to display this in our component. So anyway, what we're going to do here is we're just going to display, we'll just say return. And before that, actually, let's get started by destructuring all of the properties that we need from this user. Now, you might wonder here, why is it that we're just passing through the user object, right? Presumably, this would be a JavaScript object with the user's name, email, profile picture URL, likes, dislikes, things like that in it. Why wouldn't we, you might be wondering, why aren't we actually passing each of those through, right? Why aren't we just saying name, email, what else here? Bio, likes, coworkers, perhaps, things like that. Well, I mean, that's just a design decision. And really, as far as best practices go, there isn't a best practice with regards to this. But personally, for this situation, I think that having the user be the only prop that's passed through is going to be a little bit easier, because what that means is if at any point we wanted to change the data that's being displayed in here, right? If we wanted to maybe, if we wanted to display more data, let's say that we add another property to our users in our application, or maybe we want to display a property in a different way. Well, we wouldn't have to go back through all of our pages that are displaying this component and modify the props that they're passing. All right, so that's just one possibility. Obviously, you could do that if you wanted to, and what that would allow you to do is have a page display it even when it doesn't have a user object handy, right? So maybe if you wanted to do something like preview what your updated profile would look like, something like that, if you're in the middle of updating your profile, that would be something you could do there. So there's kind of trade-offs there, but I'm just going to do things this way because it'll make it a little bit easier. And then I'm just going to destructure all of those things. So we'll say const user, name, email, bio. I'm not going to do the profile picture just because I don't have any pictures laying around here that I can use for displaying this user profile picture. But we'll just say name, email, bio, and then we'll say something like coworkers. All right. And actually, just to keep things simple, we'll remove that and we'll just say something like likes. All right. Cool. So we're getting all of those from our user object. So the next thing that we're going to want to do, of course, is just display these. And this is going to be very, very easy because there's not really any logic to be found. This is about as dumb a component as it's possible to get. All right. So here's what this is going to look like. We're just going to say we can choose a div, or one thing that I've found actually is that by not having a div surrounding all of your data, right, by just using things like React fragments instead, let's try that again. We'll just use a React fragment like this. That actually allows you to modify the container that this component is in a little bit more freely, right? So by having a div, especially a div with a class, right? Let's say that we wanted to do something like this and say div class name equals maybe something like user profile container. right? Well, the problem is that by doing that, we're setting this user info component up to be, let me think of how to say this. We're setting our component up here to be smart style-wise. And since this is supposed to be a dumb component, we don't really want it to be making its own decisions as far as the style of the container that it's in, right? Ideally, what we'd be able to do is take this same user info component with the picture, the all of the pieces of information under it, etc., and display it in a wide variety of different containers, or of containers of different shapes and sizes, right? So we might want to display this obviously in a page, which would be great, but we might also want to display it in like a little card component, right? Or in maybe a box that has a scroll bar on it. And by leaving this container off, right, by just using React fragments and saying, hey, whatever component uses this has to bring its own container, we're giving ourselves that flexibility. Now, obviously, it's got some downsides. One of those downsides is that every component that displays it now has to provide its own container. But again, that's a trade-off that you're going to have to make your own decision on. I'm just going to show you what this looks like with React fragments. Cool. So anyway, inside these React fragments, what we're going to do now is just display all of those things. So we'll start off with like an H3 heading. We'll say, we'll display the user's name. Under that, we'll display the user's email, of course. We'll just say email. Under that, we'll display the user's bio. We'll just say bio. And finally, for likes, this is where we're going to want to actually map this out, something like that. We're just going to say, here we'll say likes.map. And for each like, we're just going to create a new paragraph element. Actually, let's do a list element. We'll do unordered list, and then we'll say likes.map. And for each like, we'll just say li, and we'll insert that like. And of course, you need to add a key here. So we'll say key, and assuming that each like is just going to be a string, we'll just use that as the key. And I mean, maybe we'd probably want to ensure that those are all unique as well. But for now, just for simplicity's sake, we'll keep it that way. Cool. So anyway, this is our dumb component. And one thing, really the only thing of interest here that I want to point out is this map, is this map call inside of here. Because really this right here is as complex as you ever want the logic in your dumb components to be, right? So let's say that each like was an object with a few different properties. Well, it's going to get a little bit more complicated and a little bit more difficult to maintain if you start having to do some logic on that, right? So maybe you would have to say something like const text equals like, and maybe you want to capitalize that, so you say something like like dot to uppercase, something like that, or text dot to uppercase, that would be. Well, what you're doing there, it's kind of a slippery slope there, because once you start adding logic like this to a component, it can become very hard to stop, right? What happens when, to use a different example, let's say that you're creating some sort of financial application or accounting application, and you have to display some numbers there, and you start doing math inside of here, right? Well, that's again going to become that's going to be kind of a slippery slope, because you if you're converting from dollars to euros, let's say, inside the logic of an otherwise dumb component, then you're inherently making that component less reusable, because it can now only be used for situations where you want to convert from dollars to euros. That's something that should really be done up here in the container that you're using to display this dumb component with. All right, so that's just something I wanted to point out there. For the besides that, though, for the most part, everything else here is pretty straightforward, pretty simple, and very boring, and that is a very, very good thing in this case, right? We want our dumb components to look like this, because it just makes them very easy to work with, right? So that when your boss comes along and says, hey, could you like flip these things around? Or, hey, I want you to start displaying this kind of data on the user info component. Well, that's going to be very easy to do because look at this. This is basically a glorified template more than a React component, right? It doesn't have any state, doesn't have any logic in it to speak of, and that is a very good thing in this case. Cool, so that's our user info component. Let's move up to our user profile page, and this is going to be kind of the total opposite of our user info component, because what we're going to need to do here is all of the logic and all of the data fetching, etc., that needs to go into our user info component here. So here's what that's going to look like. We're just going to say const user profile page, and this one isn't going to take any props. And that's in fact something that you might find in many cases, is that smart components don't take nearly as many props as user info components do. But of course, you'd want this one to have some sort of state. So you'd say const use state, and probably use effect as well if you wanted to load some data, equals, and then we would, or sorry, what am I doing here? This should be import. We'll say import use state and use effect from, and this is going to be from React, of course. Cool. So anyway, now that we have those things, let's just kind of imagine what our user profile page is going to look like. And I'm not going to implement this thing totally because it's, that would just take a little bit too long, but I will give you the basic gist. Obviously, we'd want to have this user and user or set user state, right? We'd want to say equals use state and probably start that off as null or something like that. And then we'd want to have a use effect hook that actually loads that user, right? So I'm just going to put a comment there that says something like load user from database or from server, whatever, from backend. That's a little bit more generic there. For now, I'm just going to say something like set user to, and then we'll set user to something like name. I'm just going to use my own information here. If you're following along, you can certainly use your own. So name, Sean, email. This is not my real email, but sean@gmail.com. And then we'll also have bio. We'll say something like I like programming and food. And what else did we have here? Likes. We'll say, well, the bio kind of covers it, I guess, but we'll write it anyway. We'll say likes, programming, and food. Cool. So anyway, that is kind of what our use effect hook would look like. And obviously, we'd only want that to happen once, or when the when the user ID of the page changes, something like that. If we're looking at a new user ID, we'd want to reload it there by adding it to this array. But that's kind of what our user profile page would look like. And notice again that this is not very reusable code. This is only code that's going to be reusable for this specific situation where we want to load data about an individual user. Oh, and by the way, we are going to talk about this in a little bit later, but this code really doesn't belong in the user profile page either, at least not directly, because it's just kind of messy, right? And this is actually code that we might want to reuse somewhere else by creating something like a custom hook. We'll talk about that in a little bit more detail later on as well, so don't worry too much about that right now. But anyway, now that we have all of this, let's just assume that we have all of this. What we'd want to do is just return, and we'd want to display the user info component. So obviously we'll need to make that importable by saying, here we'll just say export default user info. And then we'll go back to user profile page. We're going to import that user info component. We'll say import user info from user info. Oops, let's try that again, user info. And now that we've done that, let's just go down to here, and we'd want to display this user info component with that user. So we'd say user equals user, and that's all that we'd have to do there, right? Cool. So anyway, that is pretty much all that we would need to do for our user profile page. And again, this profile page isn't nearly as reusable because there's not really any way. We'd probably only want to display this in one place, right? Maybe we'd want to reuse it if we're displaying our own profile or something like that, or maybe we'd want to call it something different in another part of our app. But in general, this is pretty much a one-off component that we're creating. So anyway, that's what our user profile page might look like. And oh, and I guess another thing that I wanted to go back and clarify on, because I feel like I probably confused some of you with my example here, is logic. The only logic that should be allowed in your DOM components is logic that has to do with formatting. So I unfortunately used that example of capitalization or something like that to uppercase, but really, converting the data that you're displaying into the proper format does fall under the job of DOM components, right? Anything, in other words, things like capitalization, right? So with our likes, we'd probably want to make sure that each of those are capitalized. And so adding that logic in here, right, and capitalizing the text that we're displaying, that's something that should be allowed. Now, obviously, you'd want to do that with a helper function. Please don't go in here and actually do the kind of messy JavaScript code for capitalization directly in this component. But that's something that would be allowed in here, right? So things like that, things like really any kind of formatting or anything that's typically allowed in things like handlebars templates is something that you can feel pretty good about putting into DOM components. But anything more complex, like any kind of data restructuring, right? So if we wanted to, let's say that we can't just load this user in this format, right? Well, let's say that we maybe have to search for the user by ID or something like that, and the data comes back as an array. Well, getting the actual user data out of that outer data structure is going to be something that the smart component should do. All right, so hopefully that makes sense. Again, this is just a very simple demonstration of the difference between a smart component, which has state and generally other side effects, and a DOM component, which doesn't. One last thing that I wanted to show you too is that let's say that you have a DOM component that needs some sort of action, or that needs to be able to trigger some sort of action, right? So maybe for this user info component, maybe we want to have a button of some sort that triggers an action, right? Maybe this adds a user, maybe this sends a friend request to this user, okay? Well, you have to be careful about that because you can very rapidly go from making a component dumb to making a component smart and therefore less reusable when you're doing this. So again, let's say that we have a button here, and this is something like add, or we'll say something like send friend request, right? Well, the time comes when we have to actually make this button do something, and if you were to go and add a function here that makes a request to the server, right? We'll call this something like send friend request equals, all right? And then inside here, you actually made a server request, and you pass it to here. We'll say send friend request. Well, voila, you've made your code a lot less reusable, right? Because now we can only use this in situations where it makes sense to send a friend request. So in other words, this doesn't make any sense anymore if we wanted to try and reuse this user info component in order to make our, in order to display, rather, sorry, I'm getting a little mixed up with my words here. It wouldn't make any sense if we wanted to use this component to display our own profile page in our settings or something like that, right? It wouldn't make any sense to have this send friend request button on there. So what you can actually do with this is obviously you're going to want the encapsulating component, right? That's probably the wrong word for that. You're going to want the parent component here to be able to pass this action down to your DOM components. So instead of having this send friend request thing here, we would want to move that up into user profile page. Right, so I'll just paste that there, like so. And then what we'd want to do is allow that component to pass that as a prop, right? So we'd say something like, and actually here, my temptation, which I'll actually show you, I was going to rename it, but I'll actually show you what my initial thought was. My initial thought was to say send friend request and let the parent component pass that through. But obviously that doesn't make any sense either, because that seems to be a very specific kind of prop, even though we could, in theory, now get this to work with another situation. The name of this prop would be quite unnerving in that case. So what I'm going to do here is I'm actually going to change this, and I'm going to say something like on action. All right. Now that might be a little bit too generic of a name. Often it can be a little bit difficult to really nail down the right level of generic versus specific in the props for dumb components. But I'm just going to use on action right now. And furthermore, I'm going to do something else, and that's going to be called something like action text. Now, what this allows us to do is if we wanted to do that, we could actually just have this button call the on click, or not on click, that would be on action prop, and we could also display that action text in this button. So here's what this would allow us to do is back in our user profile page, we'd be able to pass that send friend request as the on action prop. So we could say on action send friend request. And then for the action text, we could actually just give a textual description of what that's going to do, because that's going to be displayed in the button. We could say send friend request. Okay. And the nice part about this is that our dumb component remains very, very dumb and also very, very reusable, because over here now, let's just pretend we're writing this JSX in our personal profile page, or whatever we want to call it there. We could just say user info, user equals whatever user you loaded for yourself, your own user data from the server. And then you could say on action equals, and let's say you want another action there. Let's say maybe you want that action to be something like enable editing, right? Let's say that you on the personal profile page, you have your picture, you have your information here, and then you have your bio. Well, maybe that button down at the bottom of this thing enables you to edit all of that, right? Maybe it kind of displays another component that has text boxes in place of all of those with the correct values, or with the current values inside of them, right? Well, that's what you could do just by the way that we've designed this component. We could say on action equals enable editing, and then we could say something like action text equals edit info, right? That would basically, you'd be able to specify whatever you wanted for those cases. And to take this a step further, you might want to even be able to display this user info component without any action button at all. And in that case, what you could do is you could add some display logic in here. Remember, that's the only kind of logic that should ever be allowed inside dumb components. But you can add some display logic in here that checks to see whether that action text and on action exist. Maybe you just want to check to make sure if on action exists. So in that case, you could just say on action and button, and that would only display that button if that on action prop was specified. Otherwise, it would just hide that button entirely. All right, and in that case, if you had another page where you were displaying this, let's say that you're displaying it inside inside some sort of card, or inside some kind of list where you don't want that button at all, you could just say user info, and you could just display that user by saying user equals user and not pass any of the other props. All right, so that's kind of the idea of those dumb components, is that you can add in logic, but only display logic. And whenever, it's perfectly fine if you need one of those components to perform some sort of action, but that action needs to be passed in by a smart component. It can't just be it can't just be defined in that dumb component, because at that point you've stopped the component from being dumb, right? It's not nearly as reusable anymore once you add in that logic. Cool. So anyway, hopefully that satisfies your curiosity and at least gives you a basic idea of what smart and dumb components are. in React applications. If you have any questions about those, feel free to add those to the Q&A widget. But I'm going to move on to the next topic in our first section here, which is pure and memoized components. And actually, I see that we're at the top of the hour, so just to make sure that we don't get a lot of people dropping off to get coffee or get a snack or something like that, why don't we take a 10-minute break, and after that we'll come back to this pure and memoized components thing and go through the same kind of example. I told you, by the way, that these component best practices, since components are such a fundamental part of React, these are going to take us quite a bit of time. So, if you want to jump ahead to any of the other topics, you can feel free to let me know in the Q&A widget. But I'm going to be spending a lot of time on these for now. Cool. So anyway, let's take a break. I'll answer some of the questions in the Q&A widget after we get back. And here, let me just push out that break timer here. There we go, 10-minute break. And I will see you all in 10 minutes. Right, welcome back, everyone. I hope you had a good break, and let's just jump right back in. Oh, and before we do, there is one thing that I wanted to mention at the beginning of the course that I somehow forgot to do, and that is, you may have noticed the very brightly colored shirt that I have. Um, Andrew mentioned at the beginning of the course that I'm a trainer with CBT Nuggets. So if you're enjoying the content that you're seeing here right now, please feel free to go check out my content on cbtnuggets.com. It's honestly, I have probably close to 100 hours of React related content. So lots of stuff like this. In addition to things like project walkthroughs, right? I walk through how to build different projects that incorporate different technologies with React. So please feel free to go check that out. And well, I hope to see you there in video form. So anyway, let's keep moving with our slides here. Oh, actually, I wanted to answer some of the questions first. And that is, all right, I guess I'll just start from the bottom. There's lots of questions. Wow. Okay. Let's see here. Okay, so one question here is, are we going to be talking about state management best practices? So by that, I'm assuming you mean React or MobX or any of the other, Recoil, any of the other state management tools that are out there. I hadn't originally planned on talking about those, but if you want, I can mention those a little bit, because honestly, those are very useful. Those are all very useful tools. So I'll do my best to throw that content in there. The next question is, any reason to choose Create React App over Vite or Vite, I believe it's pronounced? Not really. I just generally use Create React App just for prototyping, and since all of these are going to be pretty simple projects, I just figured Create React App would be an easier choice for it. But you could use Vite if you wanted to do that for all of these. For all of these examples, and it would be the same kind of thing. Really, this is more of a demonstration of like core React functionality versus any kind of library or setup. So anyway, let's see here. Next question here. What command did you execute in order to create a new React app? Do I need to install? What do I need to install in order to create these projects? So in order to first of all, obviously, you're going to need to have Node.js installed. I guess I probably should have had a slide about that. But you're going to need to download and install Node.js, and you're also going to need to install Create React App globally in order to do that. I think that that happens automatically if you run the command, and then you just need to run the command npx create react app and whatever you want to call it, or wherever you want the new folder to be. That's all stuff that you can find, by the way. If you just Google Create React App, it'll walk you through all of those steps. All right, so next question here. Here we go. So this one's kind of interesting. Sorry, I was snacking during the break, and I had something in my tooth. All right, sorry about that. Anyway, this question's kind of an interesting one. It says, could we send the whole component instead of on action and action text for the button in the previous example? I'm going to share my screen because that one's definitely worth discussing. So let's just go back to my screen here. And you should see Visual Studio Code come up in a second there. Cool. So the question here, which is a very good question, and also a very interesting way of doing things, but absolutely possible, is instead of having on action and action text be passed through and displayed in this button, could we just instead pass through a React component of some sort that would get displayed, or React elements? And the answer to that is you could absolutely do that. So what that would look like in this case, let me just comment this out here. What that would look like is you could say return, and then you might say user info, user equals user, on action, or sorry, then you wouldn't even have on action. You'd have something like bottom of page element or something like that. That's a horrible name for a prop, but just for demonstration purposes, you might say bottom of page element. And then what you could do is you could just put a button there that says send friend request. And this element here, of course, would still call that same function up here at the top. So you could say button on click equals send friend request. And then on the user info side of things, all you'd have to do, I'm just going to add this prop alongside these other two, is you could say, what did I call that thing? I already forgot. Bottom of page element. I'll just copy that and paste it here. All right, bottom of page element. And then what you could do is you could actually, sorry, my doorbell just went off and my dog is freaking out. All right. Anyway, what you could do there is you could just display that bottom of page element directly inside the JSX there. Now, this is definitely another approach that you could take to doing this, but it does get, in my opinion, my gut feeling is that it's a little bit dangerous because of how messy it could be, right? Because this kind of takes the whole hierarchical organization of React apps, right? Where you have one component up here, then you have, maybe two child components, and then maybe this one has two child components, right? So it's taking kind of that unidirectional flow, right? That unidirectional data flow where data just flows from the parent components down to the child components. And it kind of flips it around a little bit, right? Because in the case that we just did there, it's not quite that kind of hierarchy, right? What's going on here is we have a parent component, right? This one here. Then we have maybe a few child components. But then the parent component has its own component up here that it passes down to this child component as well. So my gut feeling there is that this is not something you'd want to do as a rule, right? You'd only want to have this. Actually, I guess something else that you could do, something that would be better to do, and this is something that we're going to be talking about a little bit later. I'm surprised I didn't think of it. I was just so excited at the prospect of passing components as props, which you can absolutely do in React if you really want to. Probably what would be better to do in this case is instead of having this bottom of page element get passed through, all right, we'll just remove those here. Ready for this one? You could just take this element and put it under the user info component, right? So you could just say something like that, and that's going to give you pretty much the same result, actually. So, and that's just going to be a lot easier, a lot more maintainable. So that would be something that you could definitely do instead, if you wanted to do that. Now, obviously, the downside there is that if you're going to have this button, if you're going to have a button at the bottom of a user info page, or at the bottom of a user info component on a pretty regular basis, you would want to reduce. You would probably want to reduce that repetition just by having this button be part of that component instead of having to have this button each and every time. So hopefully that makes sense. That is a very interesting idea. So thank you for asking that question. Let's take a look at some of the other questions here. All right. So this question, again, very, very good question. I can tell you guys have been listening very closely because there's just some great questions coming in here. This question says, would it be acceptable to make a child of a dumb component smart? For example, the dollar to euro scenario you mentioned earlier, would it be suitable to create a smart child component that is purely used for that conversion and rendering the list of smart child components from the parent? Or is the top-down smart to dumb approach pretty much always preferred? So on a high level, right, on an architectural level, the state is generally going to be best if it's concentrated in those higher up components, right? Just because that's generally where the different needs of your application are naturally organized, right? Think about this. If you have a products page and a shopping cart page and maybe a blog page on your site, then each of those, your site is already separated into some pretty well-defined features that in theory could just be separate parts or separate applications altogether, right? You could have, a separate blog application and a separate shopping cart application and a separate products list application if you wanted to. So because of that, I think that in general, you're going to want the majority of things, especially like data loading, you're going to want the majority of those things to be higher up in your application. But nevertheless, there definitely are some situations where a dumb component can absolutely display a smart component, right? So it's not, there's no rule against that. But in my experience, what those dumb components with smart components inside them are going to be doing, those lower level smart components are going to, like, if they have some sort of state, it's just going to be state. It's not going to be doing things like data fetching. Almost never will you want your lower level components to be doing their own data fetching unless you have a very good reason for doing so. I mean, maybe I could see something like a chatbot or something like that on a lower level, but even that would probably be something that would be best concentrated up in the higher levels of your application, so that if you wanted to allow, let's say, your chatbot to take the user to a specific place in your application, which would be pretty cool, right? Or maybe the user can ask your chatbot to give them a walkthrough of the functionality of your site. Those would be things that you could really only do if that logic was concentrated up in the top of your application versus on a very lower level. So anyway, hopefully that answers your question there. But in many cases, when you have a lower level stateful component, a lower level smart component, it's got something to do with the user interface. So a very common example here, and one that I actually kind of like, is sometimes on sites, right? And in fact, this could be the case on our site here. Let's just try and draw our user profile component again. For those of you just joining, this is the picture. This is the user profile picture. It would have the name, email, maybe bio underneath that. Maybe we added a button down there at the bottom. Now, what you might want to do in certain cases is make these fields editable just by clicking on them, or by clicking maybe a little pencil icon next to them. So I've seen that on a lot of sites where you'll have these text fields, but they'll actually be, or not even text fields, where you have these like just basic text displayed in like a paragraph tag, but then you'll actually have a little pencil icon or something like that next to them. And by clicking on that, that automatically transforms this next to it into an editable text input, right? So that would be a great example of a stateful, or we'll call it smart here, lower level component, where it's a component that actually allows you, that actually has different states, right? So in this case, you'd have kind of an editing state and you'd have a viewing state, right? And that would be something that I don't even know that I would necessarily call that smart, because at that point it's not really doing anything that has any far-reaching effects in the application, right? It might, I mean, obviously, eventually when you edit that, it's going to have to send some sort of event up in the chain, but so that some higher level component actually makes that request. But as far as just being able to manage the appearance of this and transform that from a paragraph into a text input and back again, that is something that would be on a very low level. And I mean, in this case, this kind of component is going to be on the very bottom of the component tree, right, or on the furthest leaves, right, the furthest branches of the component tree. So hopefully that answers that question. You can absolutely have smart components, further down in your application that are contained by dumb components, but in general, those components are the only smart functionality they're going to have is keeping track of some kind of state related to their display or something like that. So anyway, let's take a look at the next questions here. All right, I think some of these I've answered like while I've been discussing other things, so I'm just going to mark those as answered. But what else do we have here? Okay, so this one's sort of related to the question I just answered, but I like this one too, so I'll discuss it a little bit. This question is it a good practice to have a dumb component which functions in different modes where it displays data differently? For example, view mode, edit mode, etc. Or would you advise creating separate components on certain occasions, even if there are some core similarities between the different modes? So that brings up a very good point. And in general, what I would recommend in that case is, well, the question here would be, is it recommendable to have some sort of mode that gets passed down to this component where maybe the default is view, but it's also got an edit option that would display all of these things as, let's say, text inputs? That's definitely something that you can do, and there is a trade-off in splitting this into multiple components, but in general, I would recommend that you split that into multiple components. And what that would look like is, instead of just having, there we go. I'm going to try and draw this again with my mouse. But in that case, what I would recommend is, instead of having, well, let me start that sentence over. In that case, what the application would look like is, you'd have these circles here that I'm drawing are components. We'll just call this the user profile page component. All right, and then this is obviously displaying the user info component, UI. Well, again, let's say that you wanted to have multiple modes. Well, you could have, what you could do in that case is, you could have this user info component be either in view mode or edit mode, just by passing a different, a different prop down to it, right? So you could say view, man, that is hard to write with a mouse. You could say view, or you could pass edit, and that would change the appearance of this user interface. However, that is going to add in, I'll say it this way, that's going to break a different rule than the specific rule that we're talking about here, right? That's going to break the rule of lean components, which we'll talk about a little bit later, because in that case, what you'd be doing is, you'd really be having two components in this user interface, or this user info rather component, that are kind of switched on or off. So I wouldn't recommend doing that. What I would recommend instead is having some sort of switch component in between the user info and user info edit component, right? So that would be this this component right here. That'd be sort of a switch that would determine whether this should be in view mode or edit mode, and it would just display different components depending on that, right? So over here, maybe you'd have the user info view component, and over here you'd have the user info edit component. And again, there is going to be a little bit of duplication there, just because both of these components down here at the bottom are going to have a very similar structure and a very similar series of fields that they're displaying. But ultimately, that's just kind of a sacrifice you have to make in order to keep those components lean, which again is something that we're going to talk about a little bit later. Cool. So I think that's all the questions that I'm going to have time for now, but I'm going to come back and feel free again to submit any more questions that you have while I'm going through the next bunch of content here, and I'll answer them after the next break. Cool. So let's go back to our slides here, and where we left off, we were discussing the topic of pure versus memoized components in React. So just to give you the basic idea here of pure versus memoized components, in order to understand why these types of components are, in order to understand why these types of components are important, you really have to understand how re-rendering works in React. And that's something I can definitely take you through if you'd like, because a lot of people get the basic idea that React only re-renders the parts of the interface that change, etc., but they don't really understand how that works in specific and very common situations. So we can go through that, but basically the idea of pure and memoized components is that they increase the performance of our application by cutting out unnecessary re-renders in our components, right? So for things, they basically automatically compare things like prop and state for a component to determine if it's worth the trouble to re-render them. That's the main idea. We'll take a look at this in code very shortly, because again, this is something that Generally, when I've seen memoized or pure components used, unfortunately, it's just where the person has been trying to find an easy hack to improve the performance of their application, and just kind of adds it just kind of adds pure components and memoized components to all of their components, and that can cause some very strange bugs in your application. So not something I recommend there. But anyway, really what pure and memoized components are best for is components with a very simple state or props. So in other words, these are going to tend to be favored for dumb components over smart components, at least components that are a little bit further toward the dumb side of the spectrum. So, and really, again, what it does is it improves performance, because if you do it right, and if you do it with the right kind of components, which we'll talk about a little bit later, this can really cut out a huge amount of the of unnecessary re-rendering, unnecessary code that React would otherwise have to execute. So let's go to the next bullet point here. I think I already said that. Really, what it's best for is static data, right? Things that don't change frequently is what these kinds of components tend to be best for, right? So again, if you're displaying, if you're creating maybe a I don't know, let's say a blog site, or maybe the user profile example might be a good example too. These components would be great for that. However, if you're creating something where the interface is changing constantly, right? It's everything's kind of getting shuffled around, etc. Then these may not be the best. These may not be the best types of components for your needs. Another thing too to keep in mind here is that these are not ideal for deeply nested objects. So if you're, this actually goes back to one of the components that we created, right? This user info component. If we're passing this user, and let's say that this user gets more complex, or if we're working with more and more deeply nested data, then that can start to cause some problems. We'll take a look at that a little bit later as well. But anyway, the way that these things are actually used, we'll see this in code in just a minute, is by extending React.pure component. This is if you're using, of course, class-based components in React, or you can use the React.memo higher order function, which is used with function components in React. So let's jump over and take a look at what these things look like in code. What I'm going to do here is I'm just going to close user profile page and user info for now. And I'm going to create two more files. In fact, let's create a folder for the, just based on kind of the demonstrations that I'm doing here. Let's make a folder called something like, what was the last thing about here? Oh, smart versus dumb. We'll just put these user info and user profile page components into there, just to kind of try and keep everything organized for you, since I'd like for you to have a, I'd like to push this all up to GitHub at the end of the course so that you can have access to it, use it for reference. And let's create a new folder here that we'll call something like pure and memoized. And inside here, what we're going to do is we're going to create a new file that we'll call something like, we'll just call it here. Let me take a look at the example that I have in my notes to see what we should call it here. Let's use a very similar kind of demonstration. But actually, before we go into that, what I want to do is just show you give you a basic idea of how re-rendering works in React, and some of the things to keep in mind with this. And these are things that a lot of people don't really know. Like, again, they might get the basic idea of React and how the re-rendering works, but they don't understand how it actually works in practice. So what I'm going to do here is I'm going to create in the, I guess I'll create it in the pure and memoized folder here. Oops, there we go. I'm going to say new file, and we'll just create a few components. We're going to call these components something pretty simple. We'll just call them a.js. We'll call them b.js, and we'll call this last component c.js. All right, pretty straightforward, pretty simple. So here's what we're going to do next is we're actually going to give each of these components some children. So we'll do something like my IDE isn't working for some reason when I want to go create a new file. We'll create a new file called something like achild1.js. We'll do another one called achild2.js. And then we'll do, I don't know, the same thing with B. We'll say something like bchild1.js and bchild2.js. That's a lot of components, but this will give us a very clear view of how the re-rendering process works in React. It should anyway. Cool. So what we're going to do here is we're going to go into our app component, and we're going to display these components. But actually, before that, we obviously need to implement these components. So let's just go through and do that pretty quickly. I'm just going to do, for A, what this is going to look like is we're going to say something like const A equals, and then we'll have this take some sort of prop, which we'll call message. All right. And inside here, of course, we're going to want to know when A is being rendered. What we'll do is we'll say something like console.log rendering A. And then down here, what we'll do is we'll say something like return. And inside here, we'll just display the string A inside this header. We'll display the message prop underneath that. We'll say message. And then underneath this, what we're going to do is we're going to display, of course, achild1 and achild2, which we need to actually go and implement as well. And here, let's just put this inside a React fragment here so that my IDE stops complaining that I'm defining two top-level elements. All right, so we have A. So let's do achild1 and achild2. These are going to be very, very simple components by design, of course. So what we're going to do is we're going to say const achild1 equals, this is going to take some sort of, actually, we'll just have this take no props at all for now, all right? We'll just say something like return, and then we'll say display an h3 heading, and this will say achild3, or not 3, what was I thinking? achild1, there we go. And we'll also say console.log rendering achild1. So hopefully you see what I'm doing by now. I'm just creating a very simplified list, a very simplified tree of components. And this will allow us to see not only what order things render in, but also when things are re-rendered and why. So here's what this is going to look like. I'm going to copy this achild1 thing, going to paste it in achild2 and just rename it. And of course, we'll need to export these. So we'll say export default achild2. We'll do the same thing for achild1. We'll say export default achild1. And then we'll do in A, we'll say, export default A. And then we'll do the same thing for B. So I'm just going to copy this and put it in B and C. All right. And then, of course, we just have to rename these things. We'll want to say rendering B instead of rendering A. We'll want to display B here. We'll leave that message thing for now. And then we'll say export default B. And now we're going to do C. So we'll say export default C. We'll rename this to C. And we'll say rendering C. And then we'll say C in the heading there. All right, so the last things we need are just, we need bchild1 and 2. So I'm just going to copy achild1, paste it in bchild1. And rename it, of course. So we'll say bchild1, bchild1. We'll change what we're logging out there. And then we'll say export default bchild1. And last but not least, bchild2. All right. And we'll say rendering bchild2. And the heading is going to be bchild2, export default bchild2. Cool. So that was a lot of component making there. So let's go back now and actually add these child components to A. So we just need to say achild1. That just got imported for me automatically, which is nice. And then we'll have achild2. So we'll say achild2. Oops. There we go, like so. And same thing for B. We're just going to display B child 1 and 2. So we'll say B child 1 and B child 2. There we go. Cool. So sorry for that very lengthy amount of setup there. I kind of wish I'd foreseen this this demonstration here, because what I wanted to do, I would have just had all of this set up ahead of time, but the idea to demonstrate this occurred to me when I was talking about pure and memoized components, because it occurs to me that probably the things that pure and memoized components fix, many people don't understand the quite how that works, and that, as I already said, can tend to just lead to people throwing these things on their components and praying basically that it's going to work. So obviously that's not something that is going to be good for you in the long run. So I wanted to set all of this up just to demonstrate how re-rendering in React works and show you in detail how pure and React memo components work. So anyway, we have these components, and just to show you the basic structure of this, what we're going to do, actually here, let me write all of these out, and I'm going to add them to our app component here in a minute. But what we're going to do is we're going to have our app component here actually display A, B, and C. So we'll say app, like so. Again, I'm writing with a mouse here, so sorry if this is all sloppy. And then app is going to display A, B, and C. And then A, of course, is going to have A child 1, which I'll call AC1, AC2. And then B is going to have 2 children as well, which we'll call BC1 and BC2. That's very sloppy, but there we go. Cool. So that's going to be the basic structure. And the interesting part that you're going to see here is how the re-rendering works according to when things change in our application. So here's what we're going to do. We're just going to delete all of this extra code, all of this default code that Create React App gave us. We'll remove logo. We'll remove app.css as well. And then what we're going to do is we're just going to display our A component, which hopefully will be automatically imported for me. Nope, let's try that again. Say A. Just going to click on that there. There we go. All right, it was automatically imported, which is great. We'll want B now, so we'll say B. That was automatically imported as well. And then we'll display C, like so. Now, again, A, B, and C all take this message prop. So what we're going to do here is we're actually going to add a state variable to app by using useState, of course. So we'll say import useState from React. And then what we're going to do is we're going to say const message here, and set message equals use state. And this is just going to say something like hello, okay? Great. And then also we're going to have a function here called something like reverse message. And this, really the main point of this function is that it's going to change this message around, and we'll see how our components get re-rendered in our component tree. All right, so here's what this is going to look like. We're going to say const reverse message, and this is just going to basically say set message to message.split. We're going to split that by an empty string. We're going to reverse that array, and we're going to join it back together into a string. That's how you reverse strings in JavaScript, for those of you who didn't know. And now that we have this, let's actually have a button that will call that reverse message function. We're just going to say button reverse message, or sorry, not reverse message. That should be on click equals reverse message. And there we go. So now we're just going to say reverse message for the button. And notice here that app, by the way, just in case someone's wondering here. Oh, and also I need to import C. So let's just say import C from pure and memoized C. So app in this case is really the only smart component that we have so far, right? None of our other components have any state of any kind. And let's just pass that message down as a prop to all of these. We'll say message. B is going to have that message prop as well. And actually, what I wanted to do is remove that message prop from C. So let's just take this out, and instead of the message, we'll just say something like no message for C. Okay. Cool. So here's what this is going to look like now. We're going to run our application. All right, so let's just run this thing here. Say npm start. And this should open up a tab for me. So there we go. All right, great. So here, I'm just going to drag this over for you. All right, so here we see our wonderful, wonderful demonstration app, which has A, B, and C, and it also has each individual message displayed here, as well as two child components that don't really do anything. And oops, it looks like I did something wrong there. So a child 1 needs, oh, here, I never changed that. That should be a child 2. Oops, let's try that again. A child 2 and a child 2. And then we're going to want B child 2. It looks like I already did that one. Okay, cool. So let's try that again. It looks like it's already updated for me. And if we open up our inspector window here, here's where we're going to get insight into how this whole process works. Sure enough, we see that it says rendering A. And by the way, you see these things twice. That is the React strict mode, I believe, where basically what that does is it makes sure that we don't have any faulty logic in our use effect hooks, things like that. But anyway, we see that A is rendering first, and then both of A's children are rendering first. And oops, it looks like, did I forget that log? Oh, there we go. Okay, I just needed to refresh it there. So anyway, A's rendered, then A's children are rendered, then B's rendered, then B's children are rendered, and then C is rendered. So the first thing to notice here is that React has kind of a depth-first approach to rendering things. So now let's see what happens. I'm just going to clear this out. Let's see what happens when we click reverse message. And remember that that's going to change the prop that's getting passed into A and that's getting passed into B. So we're going to say reverse message. And let's take a look again. And it looks like pretty much everything here has been re-rendered. Well, the reason for that is because when a component, our app component in this case, when a component's state is changed, the whole component's just going to be re-rendered, right? That's just something that automatically happens in React. And what that usually means is that all of its child components are going to re-render, and therefore all of their child components are going to re-render, etc., right? And this is actually, by the way, sorry, I just needed a sip of tea there. This is actually something to keep in mind when you're deciding where your state should go and how far up to put those smart components, because when the state of a smart component changes, it is going to need to re-render everything underneath it. So that's just something to keep in mind. And what we're going to see here can really help with that, right? It can allow you to have your smart components higher up in your application while not sacrificing performance by having to re-render everything further down the line. All right, so anyway, let's take a look now at what happens if, let's say that A has its own state. What we'll do here is we'll just we'll say import use state from React. And now what we're going to do is we're going to say, we'll create another state, but instead of message, we'll just say something like name. So we'll say const name and set name equals use state. And I'm just going to use my own name here. You can definitely use your own name if you want to. And then we'll just do the same reverse functionality with this. So we'll say, here, in fact, I'll just copy this from the app component. We'll just say const reverse name. All right. And this is going to say set name to name.split.reverse.join. All right. And then we'll display the name down here. So we'll say paragraph tag, and we'll display the name here. So we'll say name. And now we're going to put a button in our A component that actually calls reverse name as well. We'll say reverse name. And on click, of course, this is going to call the reverse name function. Cool. So far so good. Let's go back now and take a look at how this re-rendering works. So I'm just going to hit refresh. That should reset our entire app. Same re-rendering order as we've seen. And now what we're going to do is instead of clicking the reverse, oops, let's try that again. Instead of clicking the reverse message button down here at the bottom, we're going to click reverse name. And as you can see, that's only going to re-render A and its children there, right? So B and C are not getting re-rendered at all. Now, the reason that I'm showing you all of this, part of the reason is that this is generally a reason why people will try and concentrate their state logic further down in their app in order to try and increase performance, right? Because if you have a fairly complicated app and all of your state is up in your very top component, well, that's going to cause your whole app to re-render. That's going to cause all of your components anyway to it's going to cause all of your function components to be called when that happens. Now, I guess I probably should mention here as well that when these components re-render, that doesn't mean that the entire HTML that's being generated here is being replaced each and every time. It's not. In general, only the parts of the interface that are changing are being modified, and that's where React has a big performance boost over just kind of just doing things like re-rendering an entire template, because interacting with those elements can be kind of expensive. So you can actually see this, by the way, if you open up your elements and click reverse name. Oops, here we need to actually open this up. You can see that that's actually changing because our the dev tools actually highlight that when that changes, which is pretty cool. And you can see that with reverse message as well. Yeah, let's just open up our message things there. You can see that it shows that those are the only things that are actually changing. Okay, so nevertheless, though, it can be sometimes very expensive to call our components if they're a little bit more, if they're a little bit more complex. So what we're going to do here is I'm going to show you how the React memo function allows us to avoid even calling these functions again in the first place. So what this is going to look like, you may have noticed that our achild1 and achild2 components are both getting re-rendered, even though there's absolutely no reason for them to re-render, right? We know that there's nothing that's going to change there. So what you can actually do here is use React memo to prevent that. So here's what this is going to look like. We're just going to say, here, hold on just 1 second here. All right, there we go. We're just going to say import memo from React. There we go. And then we're just going to wrap this function in this memo function, this memo higher order function. And basically what that will do is it will automatically check whether things are changing and decide whether or not to re-render this component. So I'm going to add that to achild1 and achild2, and we'll see what that looks like. So we'll say import use memo from React. There we go. And then we'll add, actually not use memo, sorry, that's just plain old memo is what we want here for now. There is a use memo thing there as well, but we want memo, just plain old memo for now. So now let's rerun our application and see how that changes things. What we're going to do, oops, there we go. You might have to refresh your application there, but let's open up the inspector window, and we can see that achild1 and achild2 were still rendered, right? Those functions were still called at the beginning of the application. That's obvious, right? We needed to get their JSX in order to render them in the first place. But now what we're going to see is if we click reverse name, it's only going to re-render the A component, right? Because again, React memo is seeing that there's no difference in props because there are no props, and it's making it so that those components aren't called, right? So if these components had a fairly large, and especially a fairly large DOM interface that they were displaying, this memo could potentially really increase their performance. So again, going back to, for example, our, let's take a look here. Back here in our smart versus dumb, if we were to add memo to our user info function here, then that would be, that would obviously be a very, that could potentially be a very useful thing. However, there is one problem with this that I'll discuss a little bit, that I'll discuss by incorporating it into this dummy application that we've created. And that is, well, so first of all, let me tell you what memo does. Memo actually just checks to see whether any of the props have changed, and if they have changed, it's going to call the function again. If none of them have changed, it's not going to call the function. So what that means is, let's say that C over here, let's say that instead of taking a message prop, it takes another prop called something like, I don't know, my prop, okay? And maybe it displays that down here. We'll say something like P, my prop, and then we'll display the value of my prop here. Well, what we're going to do is if we pass in my prop to C, we'll just say my prop like so equals my prop. Well, C is still going to be re-rendered here whenever message changes, right? Or whenever our app component re-renders, because that's just how it works. However, because this my prop thing isn't changing, and actually let's create another state variable in here so we can demonstrate this. We'll say my prop and then set my prop. And then we'll say equals use state, and we'll say something like goodbye, okay? Well, in this case, what's going to happen is, well, here, let's create another button here that increments my prop. So we'll say set my prop, and then we'll say, actually, we don't want that to be a string then. We'll want that to be a number. We'll just say use state 0, and then we'll say set my prop to my prop plus 1. All right, so we're just going to increment it like that. And then we'll say something like increment my prop. Cool. So if we were to go and memoize C now by saying import memo from React, and we'll wrap this, of course. We'll say memo, we'll wrap that whole component like so. What we're going to see is that if we change any other thing about that, let's just, oops, something went wrong there. Too many re-renders. What's going on here? Oh, duh. That's because that was a rather silly mistake on my part. We need to actually make that an anonymous function there. Cool. So let's try that again. We're just going to go back to our tab. And now let's take a look at what happens when we re-render things, right? Just going to stop that. If we click reverse name now, that's only going to re-render A. If we click reverse message now, that's only going to re-render A and B and its children, right? And it re-renders B child 1 and B child 2 because we haven't memoized them, right? That's just going to be the default there. Now, as far as C, if we click increment my prop, we can see that that's only going to, well, actually, that's going to re-render a lot of things because these things haven't been memoized either, right? Now, memoization, you should know, doesn't affect state at all, right? So in other words, that's something to keep in mind when you're considering whether a component would benefit from memoization, is how often does that state change? So going over to our A component, we could memoize this component, right? We could do that by saying use state and memo, and then we'll just wrap this in a memo function like so. And what this is going to do in this case is it's only going to re-render A when message changes. So if we go back again to our code, and let's just open up that inspector window again, we're going to see that if we clear this and just do increment my prop, which remember only affects C, A is no longer going to be rendered, right? Now, that's, again, just because A is only now listening for changes to this message prop. However, it's still going to pay attention to this state that we have. So if we go up here and we click reverse name, it's going to re-render A, right? Now, here's the thing that you need to keep in mind is when you've memoized a component, with state, that is, like this A component here, that's only going to that memoized response, we'll call it, that memoized return value, that is only going to be kept until the state of A changes, right? So in other words, the first time that our application comes along and calls this A component, it gets back a certain amount of JSX. And what we're doing by saying memo is we're saying that unless that message prop changes, we shouldn't re-render that thing, or if the state changes. Now, when the state changes, React knows that that's going to invalidate any previous JSX that it got back from this function, because that could completely change the way that that data is rendered, right? It could completely change the way that those props are rendered. So it's just going to throw out any memory that it has of the previous return values, and it's going to need to recalculate it again. So that's just something to keep in mind, is that whether or not to memoize a function is going to depend on how often its internal state changes. So if you have a component that has a state, but maybe that state only changes at the very beginning when you're loading data, let's say, and it doesn't change at all after that, then you might want to use that memoize, or you might want to use this memo function in order to improve performance, because again, it's going to apply. It's going to be helpful in every situation until that state changes. Now, on the other hand, if you have a state that's changing very frequently, right? Let's say maybe you have a state that updates every few seconds, then memoize isn't really going to do very much good for that component, because, again, every time that state changes, it's going to invalidate any previous memoized JSX. So anyway, hopefully this is all making sense so far. I feel like you probably have lots of questions about this demonstration in particular, because it's a little bit much to keep track of. But anyway, we have actually reached the top of the hour. So what I want to do is, I'll answer some of the questions now, and then we'll take another break, and then we'll move on. Maybe we'll even move on to the next section, so that we can, because we've been talking about components for quite a while now. But anyway, let me take a look at some of the questions about this topic here. So this one says, memo seems too good to be true. What are the drawbacks of it? Well, really the main drawback, and this is actually something I haven't mentioned yet, the main drawback is that memo does have a little bit of overhead associated with it, right? Basically what's going on behind the scenes with memo is the first time we render, or the first time we call this function, right? I'm just going to try and draw that function here like so, right? The first time we call that function, it's going to return some JSX, right? So it's going to have, I'm just going to draw that as a series of dots. Nope, there we go. Dot, dot, dot. Right, so it's going to return some JSX. And because this function, in many cases, because these functions are what are known in the functional programming world as pure functions, in other words, the only thing that will change their output is a change in the arguments, or in this case, props or state. React takes that JSX that was returned and it saves it, right? So it's going to remember what this JSX was. And so the next time the function gets called, it's going to check to see, okay, are all of these props the same? If they are all the same, then it knows it doesn't even have to call that function again. It's just going to return that saved JSX. Now, again, this does have a little bit of overhead because of the fact that React now has to save these previous answers in memory. So that's kind of the downside, right? And that's why you only want to use memo in functions that are actually going to benefit from it. Because, again, if a function has a state that's changing all the time, that's just not going to be very helpful, right? That's going to invalidate the memoized value, React is basically just going to throw this out, and you'll have done all of that for nothing. So that's the downside for memoization is really you want to memoize functions that are actually going to benefit from it, right? So you're going to want to memoize functions that are getting called, or you're going to want to memoize functions that are maybe a little bit further down in the tree that are getting re-rendered a lot, such as achild1 or achild2, but are never actually going to return anything new. Now, in both of these cases, since these components are too small, it might not even be worth it for these two things. But you can always try it and see what the performance benefit is. But it's definitely not, Memo is not just a panacea where it just, you can fix any performance problems with it. Cool. So hopefully that answers your question there. Let's see here. I think that I've answered when should you not memoize. Hopefully that answers that as well. Are there any tips to decide whether a component should be memoized? Really, the main thing that it comes down to is the amount of logic that component has inside of it, right? How expensive that component is to call. So again, if your component is doing things in there like making network requests, or if it's got a fairly large interface that it's rendering, that's something to keep in mind. But the other thing to keep in mind is how often that state is changing. If the state's changing very, very frequently, then it's probably not worth memoizing. All right, so hopefully that answers your question. Let me see what other questions we have. So this question is, can you wrap only part of a let me try saying that again. Can you wrap only part of a component inside Memo? The answer to that is no, but what you can do, of course, is you can just take that part that you want to memoize. Let's say that we wanted to memoize, I don't know, this part of component B. You could take that and just put it in its own component and memoize that component. So that's how you would go about doing that. Let's see what else we have here. All right, let's see here. Okay. I think that is pretty much all of the questions. Oh, one last question here says, is Memo able to check the reference object from the useRef hook with a complex structure? That is another thing that I actually wanted to mention. So thank you for reminding me of that. Memo does what's known as a shallow comparison. So what that means is if you're using something with a fairly complex structure, and especially if you're not replacing the object. So going back to here, let's see here. Let me open back up the user info and user profile page examples from before. Oops, what did I just do there? There we go. All right, so remember that for this user info, I specifically passed a user object here, which it's not a super complex structure, but it is an object, and it does have this likes array inside of it. So let's say that one of these likes changes. Well, if we were to try and memoize this thing by saying memo, and I realize I'm not importing it, I'm not going to actually run this, there's a potential that any change in this user object wouldn't be picked up. And here's what that would look like. If we were to go back to user profile change, and maybe we had, maybe we wanted to update the user in some way, right? Maybe we have some kind of update user function, and maybe what that does is it changes the user's, or maybe what it does is it adds something like React to the user's likes. Well, what that might look like is you could say user.likes.push, and you could add React onto there. And then you could say set user. Well, the problem with this is we'd be setting the user to that same object, just with something changed in that object. And React would not pick up on that in memo, in the memo function. So that's something to keep in mind. What we'd actually have to do there if we wanted that to re-render is we'd want to actually say something like set user to user, and then we'd have to specifically copy this by saying user.likes or here we'll say user.likes, and then we'd add React in there. Now the problem with that would be that if we were just copying that user object, and let's say that this didn't actually cause any changes, that would actually cause that memoized component to be called again, because this would no longer be that same object, right? What am I trying to say here? The comparison that React Memo is doing here behind the scenes is it's taking a look at the old user in this case, and it's checking to see whether that's triple equal to the new user, right? So in the case where we're creating a new object, a copy, that's always going to be false, right? Whereas in the case where we're just editing a property on there, that's always going to be true. So in other words, with objects, it really doesn't work very well with Memo. Now there is since you guys seem pretty interested in Memo, I'm just going to show you this before we go on our next break. There is actually here, I'm just going to remove Memo from those. There we go. There is actually a way that you can do this, and I'm not sure why I closed those. I actually wanted those up again. So here, let's go back to user info. We'll add Memo back on. All right, like so. And oops, let me add that extra parentheses there. Cool. So there is actually another way to tell Memo what it should compare. So let's say that we know that this user shouldn't change except for maybe the user's name, right? Well, what we can do there is we can actually specify our own comparison function by passing a second argument to this Memo function. So we can say something like, and here, let me get the exact syntax of this. Here we go. So this is actually a function that we pass with the previous user and the next user, right? That's the old value of the user prop and the new value of the user prop. And in this case, what we would do is if we only wanted to compare the name, we could say previous user.name is equal to next user.name. And what this would do is every time React is trying to determine whether or not it should re-render this component, it's going to come down here and check this with the previous and new values. And if this returns true, it's going to assume that it's equal and it's not going to re-render. If it returns false, it's going to mean that something changed and it needs to re-render. So that's another option that's available to you when working with React Memo. But again, I'm just going to remove Memo for now because I don't want to clutter up this component from the old example. So hopefully that answers all of your questions there with memoization. And by the way, pure components, I didn't mention those. Those work in a kind of a similar way to memoization, except for the fact that they work with class components. So a pure component in class syntax would look like this. We'll just say something like class pure.js, and we would just say something like class pure. Kind of a bad name for that, but we would say extends. And we want to extend React's pure component. So we'd say extends pure component, and that comes from React as well. We'd say import pure component from React. And what pure component actually does is it automatically does a shallow comparison of both the props and the state of the component whenever React is trying to determine whether to update it or not. And based on that shallow comparison, it might not call render, right? It might just basically leave it the way it is, same as what we had with React Memo. Cool. So anyway, hopefully that answers all of your questions there, and I'm just going to leave that there, I guess. So let's take another 10-minute break, and when we come back, we will move on to the next topic. So I hope this is going well so far, and I will see you all in 10 minutes. All right, welcome back, everyone. I hope you all had a great break. So let's just continue on with the with our topics here. I already covered most of the questions from last time. So if you have any more questions with regards to memoization or pure components, as I'm sure you probably do, then feel free to add those to the Q&A, and I will answer them in the next Q&A session. All right, so I'm going to go back to my slides here, and what I actually want to do, I did have a few more things I wanted to talk about with as far as components, but I want to skip ahead to the next section, and that is a section where we talk about the overall organization and structure of our React projects. So let's just go to those slides here, and I can always come back and talk about things like function versus class components if you want, but composition, prop types, default props. Those are all in the slides. So feel free to take a look at the PDF slides. And if you want me to go back and discuss anything, I definitely will. But let's jump to section 2, which is project structure and organization best practices. So really the main thing that I want to discuss here is how should you organize the files and code inside your React projects, right? So once you've, besides topics like how to work with individual components, how should all of that code be organized in your, in your React projects? That's what we're going to be talking about here. We're going to be taking a look at the difference between component folder structure, whether we can use feature or function-based structure. That's something that we'll talk about here. We're going to be taking a look at how to keep our component files lean and some of the benefits of doing so. And we're also going to take a look at the idea of helper and utility functions and where to put them in your code. So those are the main things that we're going to be focusing on in this section. And again, I wanted to just jump ahead to this section because we've already spent, 2.5 hours or so on the component stuff. So in an effort to make this not about React components, not all about React components anyway, I wanted to move ahead here. But again, if there's anything you want me to discuss from the component section, feel free to put that in the Q&A, and I will go back to it at some point later in the course. Cool. So let's get started here by talking about the basic folder structure of our applications. Really, there are two options, and this may be a false dichotomy, right? There's probably many more shades of gray in between these two things, but for our purposes now, let's just pretend that there's only two options, and those are feature-based and function-based. So function-based structure is probably, I don't really know why this is the default for most people, but it is usually the default, right? When people even when beginner developers in a boot camp or something like that use are learning how to program, they use function-based structure almost by default. It's kind of interesting how that happens. I think just because at that point we're trying to learn all of how all of the different pieces of an application fit together. So like the front end, the back end, the database, etc. We tend to make those distinctions. We tend to let those distinctions define the entire structure of our application. So what function-based structure is, we'll just use this kind of this working definition that I have here. Function-based organization organizes by file type. And by file type, what I'm referring to is like what part of the app on a vertical level, we'll say, that that file belongs to, right? So you might, what this means is that you have a top level folder called something like server endpoints, or maybe you'd have a top level folder called database schemas, or maybe even ones called things like pages or lists, right? So in other words, you're organizing files by, you're organizing files into files that do similar things, or into folders that contain similar technologies. And again, that's just kind of the default, right? That's chances are, if you were to look at most of your projects, I know this was definitely true of my earlier projects. That's how I organized things, because it was easier for me to think of, okay, this is front end code, this is back end code. And some of the pros of this, of course, are that it is more intuitive for newcomers because it's if you have a newcomer, if you have an intern, let's say, that's going to be doing front end development, or an intern that's going to be maybe even just working on uh, maybe the state management part of your application, or just the pure dumb interface component section of your application, then if all of those things are in the same high level file, it's going to allow them to spend all their time just in that folder, and it's going to allow them to at least make sense of that part of the that part of your project. And in general, it's just a little bit easier to locate, right? It's if you know that you need to make a change to something database related, it tends to be much easier to just go to a folder called database than to actually try and look at the feature that you have to fix, right? So if you're seeing, if you're seeing that there's a problem with displaying users in your application, and you figure out that that goes back to the database, then you're going to have to kind of figure out what that top level folder is going to be called, right? Is it called users, or is it called maybe friends, or is it called members? There, in other words, there's a little bit more room for different naming conventions in the alternative feature-based structure. But with function-based structure, it tends to be pretty easy to find the files you're looking for, or at least get reasonably close. All right. Now the cons here are pretty are pretty big ones. The first con is that this can lead to, for one reason or another, it tends to just lead to coupling in your code. And the reason for this is that I don't remember what this law was called. Chances are one of you knows this, but there's some law of software development where it says that the communication patterns in your organization will almost directly reflect how your code is organized. So in other words, if you have a function-based structure in your application, and what this would mean is that you'd have maybe a front-end folder, a server endpoints folder, and a database folder. I'm talking about full-stack applications here. We'll talk about what this looks like in the context of React a little bit later. But then chances are you're going to have one team for each of those folders, right? So you're going to have a database team, you're going to have a server endpoints team, you're going to have a front-end team. Now, generally what happens, for one reason or another here, generally what happens in situations like this is that those teams, when you just have a database team or a front-end team or a server endpoint team, then what tends to happen with that is, because they all are familiar with the same technology and they all work on the same code base, their code becomes like very tightly coupled together. Whereas when you're working in feature-based teams, right? Let's say that you're working on the product team, where you have a front-end developer, a server developer, and maybe a database developer. You can't really tightly couple those things together because they're not in the same code base, right? You're forced to communicate between those things in a very nice, loosely coupled kind of way. So that's a downside of function-based structure, is that it makes it a little bit too easy to tightly couple your code together. And this in turn can complicate scaling, right? Because let's say again that you're building an e-commerce website and you just have a function-based team and code base. Well, you might find that one feature of your application is getting used a lot more, right? You might find that maybe the products feature of your application is getting used a lot more than you thought it would, and certainly a lot more than the other parts of your team. But because your app is designed in that way, right? It's because it's layered as database, server, and then front end. You can't really split those apart and give extra resources to one of those. Whereas if you develop this in more of a microservices approach, let's say, and you have a very feature-based team where there's one team that's working on the whole vertical slice, if you will, of the product feature of your application, and that's its own standalone application, you can actually spin up as many resources as you need for that in order to meet the demand for it, while not wasting resources on the other the other features of your application that aren't being as heavily used. So that's just something to keep in mind there with function-based structure. So let's go to let's talk about feature-based structure. I forgot I had those on separate slides. So feature-based structure is really kind of, I've already mentioned it a little bit, but it tends to group features by, it tends to group the code by features or specific domains. And this has the tendency to increase modularity, right? It has the tendency to lead more toward, as someone just mentioned in the Q&A widget, I just saw that, has the tendency to kind of lead us toward things like micro front ends. It doesn't have to mean micro front ends specifically, but that's certainly something that this could that this feature-based structure would tend to lead to if we wanted it to. And again, the pros of this. Oh well, so just to give you a few different examples of this, feature-based structure in a React application might mean separating your app, right? Separating your code into the different. Here's what we'll say. We'll say the different features that would be recognized by non-technical people, right? So let's say that you were to ask your non-technical boss, or maybe you were to ask the CEO what the most important parts of the organization are, and that list would obviously be very different than what you see as a programmer, because you see, okay, databases are important. Well, it's also important that we have a back end and a front end. So the features are going to be those things that your users are probably going to recognize as different parts of your site. So this again would be things like if you have a part of your site where you can look at products, right? Obviously that would handle the shopping cart as well. Maybe not. Maybe that would even be a separate feature of your site. Maybe you have another part of your site where it's kind of like a forum and different users can communicate there. That might be another feature. Maybe you have another part of your site that's a blog. That would be another feature. So by grouping your code together by those kinds of features, that has some important pros. And really one of those is that it improves cohesion. Basically, it makes it just helps your code to fit together a little better without becoming tightly coupled. Because again, generally the teams, when you're working kind of a feature-based structure, generally the teams are organized according to those features. And since you can't tightly couple code between let's say a Node.js server and a React app, right? It really can't be done. Or it's much harder to anyway. Well, that's what I'll say. It's much harder to do things that way. You end up aiming toward a nice loosely coupled structure just from the beginning, more by default than with the function-based folder structure. Another thing is that this tends to isolate development and testing, right? If you're let's say a developer working on the front end of the products feature of your application, or maybe the forum feature of your application, then it's going to be the way that you're going to design that, because you're not going to be working with many other front-end developers, the way that you're going to design that is going to be pretty independent from the other pieces of the front end of that application. So what that means is that the code that you're going to develop is going to tend to be pretty isolated just by default, right? You're not going to come to rely on all of these different pieces of code that all of these other developers are writing. And ultimately that just makes it much easier to test. And it does make it slightly easier to reuse as well. I'm not quite as in agreement with this last thing that I put on this slide as I was when I wrote it, but well, and the reason I say that is because if you're in feature-based teams and you're like maybe one of two developers working on one, or one of two front-end developers working on one feature, let's say, then you might not realize that there's other front-end developers on other feature-based teams that are doing something, creating an interface that's pretty similar to the one that you're creating. All right, so that's just something to keep in mind. Is you still, even when you're in a feature-based organization, or when your code is organized by feature, you still do need to make sure that the things that are shared between those features are communicated effectively to the other people in that functional slice, right? So all of the front-end developers need to know, for example, if you're creating, if you're working on a new helper function for loading data from the server, let's say, that's something you should communicate even across other feature teams so that they all know that that's something that they can use as well. All right, so anyway, that is a discussion of the pros. The cons, one of the cons here is that this could potentially result in deeper nesting, as well as complicating inter-feature communication. Now, really the deep nesting part, that's not as big a problem as it usually, here, I'm trying to figure out how to say this. Deep nesting usually isn't more of a problem in feature-based folder structure versus function-based folder structure, because really the difference there is that instead of having a database folder, let's say, and then inside that database folder you have products, users, and articles, it's really just kind of flipped, right? You have a product, user, and article folder, and then inside each of those folders you have database, server, and front end, right? That's in theory how that might work. So anyway, that's hopefully that gives you a better idea there. In general, the feature-based structure has become to be. Let me try saying that sentence again. It's after I've been talking for almost 3 hours, I start to become less and less articulate, unfortunately. But what I was saying is that in general, the feature-based organization has come to be a little bit more widely recognized as being a better way to do things, at least in software, right? Because what it allows you to do, it allows you to be a little bit more agile with things and actually be developing multiple features at a time without two features colliding with each other. So anyway, that's just something I wanted to point out, is that feature-based folder structure is usually preferred. And I mean, in my experience, it does tend to make things easier to it makes things easier to work with in general, right? It makes you feel like you're making a lot more progress, and at a glance, it makes it much easier to tell where all of the what all the things are that your program can do, right? If you look at a folder structure and at the top level of everything, there's like products, users, and articles, you have a pretty good idea of what that application does versus if you at the very top have front end, back end, and database, maybe something like that. You're not really going to have as much of an idea of what that application is all about and what it can do. Okay. So anyway, let's go into the next. We'll just go straight into the next topic. I don't think I can demonstrate feature versus function-based folder structure for you, but I think that in general that tends to make a lot of sense to most people. So let's move on to this, and we'll talk about keeping component files lean. Now, this is a very, very important one because it can definitely affect how maintainable and really just how readable your code is in the first place. So the first thing that I want to talk about is the single responsibility principle. And really this is, the single responsibility principle is a pretty wide-reaching rule, right, if you want to call it that, in software development. It's definitely not only applicable to React components. But in general, the single responsibility principle, what it says is that any piece of your application, right, any individual piece of your application should have one and only one responsibility. And because of that, takeaway from that is that it should only need to change for one reason, right? So in the case of React components, generally what this means is this kind of goes back a little bit to the smart versus dumb component thing that we were talking about. And that is that smart components in general are their responsibility, right? Their single responsibility, if you want to put it that way, is generally to do things like collect all the data and pass it down to their child components, right? Whereas the dumb components, their single responsibility is to take whatever data is being passed to them in their props and just focus on displaying that correctly. And that's kind of the first thing to follow, I would say, right? So, in other words, having your components be either pretty smart or pretty dumb is much better than having all of your components be kind of like halfway in between. The other thing, I mean, really, when you look at a component file, it should have one main responsibility. In other words, if you look at your component file, and if your component file is like hundreds of lines long and it's doing all kinds of things, it's, deciding whether to display this or that, it's loading data, it's making other network requests when the user interacts with different pieces of the application, that usually tends to break this rule, because it just, at that point, your component file doesn't have a single responsibility. It's got many, many responsibilities, and that generally means that it's going to be very difficult to maintain. And more often than not, you can tell when a piece of your code is breaking the single responsibility principle when, in code reviews, or when you have multiple PRs that all are trying to edit the same file, and you have a lot of merge conflicts around that file. So merge conflicts, I've found, can be a pretty good way to tell whether a piece of code can be, or it really should be, split up into multiple responsibilities. And to give you another example of this, let me just use my pen again here. To give you another example of this, we were talking a little bit earlier about having a user profile page component, right? This was from our smart versus dumb components discussion. And we were talking about having a user info component that may also allow you to edit the info on that page, right? So there was a question regarding whether it would be better to have two separate components here, right? A user info view component and a user info edit component, for example, or whether it would be best to have both of those inside the same user info component. Well, according to this single responsibility principle, it's probably going to be better to split those things apart and maybe have a third component that takes care of which one of those things should be displayed, right? So you'd have, in other words, you'd have maybe this user info component, and then you'd have an edit component down here, and just a regular old view component. Man, it's very unpleasant to write with a mouse. That's what they should do to, like, that's what they should do in detention in schools these days. They should just have kids have to write like an essay with a computer mouse. It's pretty difficult. But anyway, so I mean, if we were going to design that situation, trying to keep our component files lean and obeying this single responsibility principle, we'd probably want to have it look more like this, where we have this user info component that basically takes care of, maybe it takes care of this, of a few little pieces of state, right? Whether it's in edit mode or whether it's in view mode. And depending on that, it would simply pass on that, that responsibility to either one of these components, right? It would decide which one of these components to display. So that's kind of the idea there. Well, let's continue on to the next bullet point. I think I've said about all that I want to say about that right now. Here's another one that's really a very interesting and pretty practical thing to do. It's usually pretty easy for people to see, to find repetitive code in their code bases. If there is code that you find that's being used in multiple places, right? If you find the same piece of code in multiple components, right? Maybe you're saying const response equals axios.get, and then you have a URL, right? And then maybe you're doing something like dissecting that data. Maybe you have some error handling logic there, and maybe that's shared between multiple components. Well, why don't you just extract that into a helper function of some kind or a custom hook? That's going to ultimately make it a lot easier going forward to work with your code. Because if there's some change, right? If you decide, okay, we want to start using this other request library instead of Axios, then it's going to be pretty easy to swap that out and just not have to touch those components. And also that just goes along, keeping in with the topic of the slide here. That goes right along. That goes hand in hand with keeping your component files lean, because in general, it allows you to remove quite a bit of code, quite a few lines of code from your components when you just extract those into their own helper files. So using custom hooks for logic and state, this is one that people are a little bit afraid to do, and I'm not sure how much experience you all have with working with custom hooks, but I can definitely show you how to do those in React, because honestly, once you really get comfortable with custom hooks, your React components can be very, very clean and well, lean. So I'll show you. I can show you how to do custom hooks, but basically those just allow you to extract most or all of the logic from your components into its own file, and then that makes it a nice reusable piece that you can just kind of drop into any other component that needs it. So we can talk about that a little bit later as well. The next thing here is avoiding inline styles and logic by using separate files instead. This is this is an easy thing to follow until you find yourself with with a task where like a very specific piece of the interface needs to be changed appearance-wise, and really the easiest way to do that is by adding inline styles, right? So it can be very difficult to keep this discipline and not have inline styles and logic and just use separate files instead for that, but I would highly recommend you do that. Now, what I just said there was for styles, but logic, this also goes for that as well. So going back to the example that we had before of our user info page here, if we were to do something, fairly complicated, like if we wanted to capitalize each of these likes here, well, in JavaScript, unfortunately, there's no built-in function for capitalizing. There's only two uppercase, which converts everything to there's only two uppercase, which converts all of the letters to uppercase. So what you have to do is you have to say something like dot character at 0 dot to uppercase. There we go. And then you have to say plus like dot slice 1, right? That's basically going to give you everything except for the first letter. So that's how you capitalize stuff in JavaScript. That is really, really ugly. So what you'd want to do in that case is you'd want to have a util function for that. We'll just create a new file here called something like capitalize.js. And then we'd say something like export default. And this would just be a function that takes a string, and we would just return that same logic that we had, right? So string.character at 0 dot to uppercase. And then we would add on the rest of the strings. We'd say string.slice 1. And this would allow us again to, export default, there we go. That would allow us again to just use this new capitalize function in our other components, right? So instead of having all of this logic there, we could just say import capitalize from capitalize. There we go. And oops, that needs to be a string, of course. Not sure what I was thinking there. And also that needs, there we go. All right. Sorry, I was not thinking there. All right, cool. So now what we could do is we could just say like, then we could say capitalize, and we could just pass each like to that. All right, so that would be, I mean, that's just much more readable and much more maintainable than, just having all of that logic there. Because again, this allows you to find all of the places where you're capitalizing something very easily. Whereas if you were to, if you had logic like that, then no one's going to dare to touch that if they don't know what that does. That's kind of a simple example, but there are much more complex cases where, you might want to, where you have just inline logic that you should really pull out into a helper function like this one that we have here. Cool. So anyway, let's go on to the next bullet point. Separating utilities and data fetching and focusing on the component role. This really goes hand in hand with the custom hooks thing. Basically, you just don't want to have, even in your smart components, this goes for as well, it's really just not a good idea to have all of this logic, all of this complex logic in there, just because it distracts from the main organization, the main purpose of your component, right? It distracts you from the whole by having to look at all of these details. Whereas, if you were to just create a custom hook for all of this, and you could just say something like const user, and well, here you would just say something like const user equals use user, right? And that would just automatically, that custom hook would just automatically take care of all of that loading logic for you. You could remove both of these things here, right? So there we go. We're making our component file leaner already. And then what you could do is you could even move this send friend request thing into its own helper file, right? Since that's just making a network request as well. And you can just remove that too. So that would allow you to really make your file your user profile page, which is still a smart component, right? It still has this user state here, and it still is doing all of that data loading logic, but all of that's happening in logic defined in other files. So we can actually take a look at this user profile page and see exactly what this thing is and what it's doing, right? We can see that it's loading a user. We can see that it's displaying that user's info, that it's passing it down to the user info component, and all of that without having to root through hundreds of lines of code in order to find that. So we'll go back to that and actually take a look at how to create a custom hook a little bit later. But anyway, that's just something I wanted to point out there. And well, that's kind of the basics of keeping your component files clean. So let's see what the next topic is here. So another question just kind of related to those, just kind of related to that topic, is where should we put our helpers and util files? And this kind of goes into, and this is kind of related to the function versus feature-based organization. And really, the weird thing is that it can be kind of a difficult decision to decide where to put the helpers and utility functions, because there can be many cases where the same utility function is shared by a lot of different features in your application. So let's say that we have a custom hook, for example, that loads data from a URL and automatically retries the request if it fails, something like that. Well, that's going to be something that's very useful across your entire application. So the question is, where do you put it? Well, that's what we're going to talk about here. So the first thing, the general rule for these kinds of things is to centralize the utility and helpers directory in your, let me try saying that sentence again. The general rule is that you should centralize these utility functions in your project so that they're easy to find and easy to access, right? There's been many projects that I've worked on in the past where the utilities have been kind of hidden deep down in the, inside of the features, and that can actually make it pretty difficult to find. So let's say again that we have maybe, let's say that we're working in a feature-based organization database, and we have maybe products, which I'll just write P, because again, I'm writing with a mouse here. let's say that we have users. Maybe we have something else as well. Maybe we have, let's say, a blog, and maybe we have. Oh, hey, I wrote pub there. That's funny. But maybe we have a blog feature, and maybe we have a. We'll just do pubs. Well, maybe we have a shopping cart feature. All right. Well, if each of these is its own separate feature here, and maybe the teams, as I said earlier, are organized according to feature. Well, let's say that the front end person working on the products feature comes up with a nice utility function called something like load data from URL. I'm just going to write that out as load here because here I'll even write load URL. All right. Well, obviously, this function is something that could be very useful to the other features in the site. But if you have this buried inside a utility feature or utility folder, rather, inside this products folder, then none of the other people who are working on the other features are going to know about it, and they're probably going to create their own versions of that same function, right? They might call it different things. They might implement it slightly differently, and that's even worse because then it becomes very difficult to kind of coordinate those when you want to simplify your code base. So anyway, that's something to keep in mind, is if you just have one central folder for your utility functions, and this does have to be things that are used all across your application, things like load URL or capitalize might even be another example of that because that is probably used almost everywhere. You should have that that's probably something you should have in your util folder because it's just going to be a lot easier to find there. Cool. So anyway, that's what I wanted to say about that. The next bullet point here is inside your utility folder, you should probably try and categorize by functionality, and this will generally make it easier to maintain as well as discover different utility functions, right? And this, again, goes back to what I was saying before, where if you're bringing on new developers, if maybe you have a team of interns or something like that, you're going to find that they try and write their own code. Maybe they're trying to prove themselves or something, but a lot of that code that they're writing might be a duplicate of something that's already in the util folder. They just didn't know it was there, right? So by organizing this in a nice logical way, you're going to make it much easier for people to find and also to use. So, just to give an example, you might have a utility folder, and inside that folder, you might have something like you might have another folder like text formatting, right? Where that contains all of the utilities for formatting text. Or you might have one for networking. So the util folder in general is a folder that's going to sometimes break the rules with regards to function versus feature-based organization, because it's going to tend to be grouped a little bit more functionally since you don't ever really know what exact feature a given utility is going to be helpful for. And really the idea is that these utilities can be helpful across a wide number of features. All right, so anyway, the next thing here is to emphasize in your helpers and utilities, you should definitely emphasize pure functions for both reliability and testability, and I would add reusability. Now, many of you may not understand what pure functions are, so I'll just give you a brief explanation. A pure function in really just programming in general, it's not unique to React. These are different from pure components, but similar. I would imagine the name pure component was inspired by a pure function. A pure function is a function, and here, let me just go back to my IDE. This will be easier to demonstrate it here. A pure function is a function where the only thing that will ever change the outputs is a change in the inputs. So if we have a function called something like add, right, and it takes two numbers and adds them together, so x and y and then x plus y, well, in that case, what this is a pure function because the only way that we can change the output of this is by changing one or more of the arguments. Now, an impure function would look something like this. An impure function is where you'd have some sort of external variable, right? So you'd say something like let count equals 0, let's say. And then you might have another function called something like, I don't know, increment count. And maybe this takes an amount as an argument that you want to increment that by. Oops, here, let me rewrite that there. Amount, like so. Well, this function, if it were to say count plus equals amount, and then maybe it returns the new count, that is not a pure function because, let me try that again. That is not a pure function because we can change the output of this function without changing the input, right? So you could call increment count 2 or 3 times in a row. You could call this 2 or 3 times in a row with the same argument, right? 1. And if you were to say increment count 1 and increment count 1 and increment count 1, you're going to get different results each time, right? You're going to get, this one's going to give you 1, this one's going to give you 2, and this one's going to give you 3. So this is an impure function. This up here, add, is a pure function. Now this is important for utility functions in React because in order, if your hope is for these utility functions to be used widely across your app, this is having functions that are impure like this, or having functions that have some sort of external state, is really going to make it a nightmare to try and integrate different pieces of your application that are all using that same, those same impure utility functions. Because again, let's say that you have a component in one feature that's calling increment count, and then maybe you have another component in another feature that's doing the same thing. Well, both those components are going to be inadvertently changing each other's output just by interacting through this utility. So that is something that you really, really want to avoid. So anyway, that's really the main thing that I wanted to discuss with pure functions. And again, that's just going to make your utility functions much easier to use across your entire application, and it's going to make it much easier to integrate different features into the same application when they're using the utility functions, is if they're pure versus impure. And by the way, this also makes your functions much easier to test because there's usually no setup or teardown required, right? If a function is just returning a given, or if a function is supposed to return a given value for, let's say, if the function is supposed to return a given value for a given set of arguments, then it's really easy to test. All you have to do is call that function with those arguments, and that's it. Whereas if you have some kind of external state, if you have impure functions, let's say, then that's just going to be much more difficult to test, right? You're going to need to import all of the other pieces. You're going to need to make sure you set up the state correctly. You're going to need to make sure your test cases don't actually influence each other, and it's just going to make it a lot more difficult. So anyway, the next thing here is, the next recommendation is that you document functions clearly for long-term maintainability. Now, this really goes for functions whose functionality is not likely, sorry, excuse me, I just burped there basically. So anyway, document functions clearly for long-term maintainability. If you have a function whose functionality is going to be changing a lot over time, then having extensive documentation for that function and a pretty extensive description for that function is not something that I would recommend for it, because what tends to happen there is that the comments for the functions and the actual functionality of the functions themselves tend to get out of sync with each other, right? Someone will come along and they'll change the function and they'll forget to change the comment. Someone will come along and they'll change the comment and they'll forget to change the function. And that ultimately just makes them more confusing than anything else. However, if you're creating a very simple, if you're creating a suite of very simple, pure functions that aren't, that probably aren't going to change anytime soon, right? Such as if you wanted to create, let's say, a zip function for maybe turning two arrays into an object, then if that function is pretty much set in stone and it's not going to change because it's such a fundamental low-level piece of functionality, then you can feel free to go ahead and document that and explain what that function is supposed to do and when to use it. And that will help that function to get used more extensively because people will actually know what it does. And in general, I would recommend just having a utility folder that contains all kinds of functional programming code, right? Things like filtering, mapping, utilities like that, because that's ultimately, again, just going to make it easier to format your code and to import those things and to avoid having logic in your components. All right. And I think I've already discussed this here. Ensuring reliability by unit testing your utility functions is very, very important because of how much of your application is going to be using those utility functions. It's obviously important that you know that you're not going to be breaking those by, if you have to go in and modify them. Cool. So anyway, that is the end of that section. So this is probably a good time to take another quick break. When we come back, we're going to be discussing routing and navigation best practices. So this is going to be kind of an interesting demonstration because we're going to be talking about how to do things like lazy loading. We're going to be talking about route guards and authentication, and really just some other best practices with regards to working with React Router. And maybe after we get done with this, I'll go quickly through the security section, and then we can end with some of the other component related topics that I didn't get to discuss. So if that sounds good to you, then, well, great. If there's something else that you want to hear me talk about, feel free to put it in the Q&A and I'll answer the questions when we get back. And this probably will be our last break before we end, just because we're already, we'll probably be about 3.5 hours in after the break, almost 3.5 hours. So I'll just buckle down and just talk for another 1.5 hours when we get back, and that should be it for the course. So hopefully you're enjoying this so far, and well, feel free to submit your questions during the break. I hope to see you in 10 minutes. All right. Well, hopefully you all had a good break. So let's just jump right back in. And the first thing I'm going to do is I'm going to answer some of the questions. Doesn't look like quite as many questions showed up for this last topic. I think probably because it's a little bit less. It's a little bit more definite, we'll say, than the discussion of components. Components, obviously, since they're the building blocks of React applications, are quite a bit more complex. Just conceptually, really, to apply them to a bunch of different situations, there's a lot more of a gray area than with a lot of these other things like, file organization and whatnot. But anyway, let's take a look at some of the questions here. Um, Really, the main question that I wanted to answer here is how should you, the question, I'm reading the question here, it says, how should you balance the two approaches such that you can easily locate code while maintaining feature modularity as well? So, I mean, this is going back to the previous discussion of feature versus function-based organization. And really, the main thing to follow here that's going to make your code easier to find, whether you use feature-based or functional-based organization in general. The main thing that you're going to want to make sure you try and do is to keep your folder structure fairly flat, right? So if you have, again, if you have like the features on top and then under there you have the functions, or if you have that reversed, right, the functions on top and then the features inside of there, either one of those is usually going to be fine. I mean, not everyone has the ability to just kind of reorganize their entire software development company's methodologies and start doing feature-based teams versus function-based teams or whatever. But really, the main the main thing, and it's kind of funny because people feel like they're really organizing their code well when they're doing it, but after a while, right after they forget about the structure, it can make things very difficult to find. Is when they're when they have their folder structure too deeply nested. So again, if you have if you have a lot of code, obviously the temptation is going to be to organize all of it in into its own folders, right? Sort of like here, let me show you my bookshelves over here. I have a lot of bookshelves, and what I tried to do at first was I tried to organize it all into different sections, and it just it really just made things harder to find, right? Really, the best way to do things like that, right? And same goes for my bookshelves, is just to have like fewer folders with more stuff in them, but then have some kind of good naming convention for the files that you have in there. So this goes, I mean, this is one of the reasons why things like lean component files are so important, because if you have a lean component that is where it's really only the component, that component has one purpose, then you can just use the name of that component as the name of the file, and it'll make it really easy to find. But I've seen plenty of situations where people will have multiple components inside the same file. The file itself will be called some kind of vague descriptive word like account management, and then of course in that file you'll have like an account. You'll have an account component. You'll maybe have a button component. You'll maybe have like a rerouting component, something like that. And it just doesn't really work very well in those situations. It makes things very, very difficult to find, to the point where you can only ever find things by Control F. Now, another thing that I want to mention here, and I'm just going to share my screen again, is that really the strategy that you're going to use does depend a little bit on the IDE that you use and what tools that provides. So to give you an idea here, let's go back to my IDE. And so far, I've been doing a pretty good job of calling all of the components the same name as the name of their file, right? So we have this capitalized function that's inside this file. Actually, I didn't even give that one a name. But for user info, that's inside this file. For user profile page, that's inside this file. So if I ever want to just find, right, let's say that I'm going through, let's say that I'm in this app component and I see component A, and I wonder, okay, what on earth is component A? Well, in Visual Studio Code, what you can do is you can press, let me see what it is. My keyboard doesn't actually have any key labels on it. So I have all the hotkeys memorized just by muscle memory. So in order to tell someone, I have to actually go up here to my other keyboard, and I believe it's Command P. That's what it is on a Mac anyway. I'd imagine it's Control P on Windows and Linux. But anyway, by pressing Command P, that actually opens up like a quick open thing in your IDE. And if you know the name, right? For example, if we're trying to find this A component and you know that that file is going to be called a.js, you can just type a.js and open that right up, right? So you don't even need to know about the structure, the underlying structure of the code in that case. All right, so that's one thing to keep in mind. And for that reason too, I haven't been doing this, but I highly recommend, well, there is a downside to this that we'll actually take a look at in this section. But generally, I recommend that you use that you either use named exports for your components, right? So that would require you, in other words, to keep the name the same when you're importing it, right? So if we had exported our A component as a named export, we'd have to actually say import A. Oops, sorry, that didn't work there. Import A in curly braces from pure and memoized A. And what that does is it forces you to use that same name down here in your code so that you don't have to go up at the top and look at that file name when you need it, right? You can just, you can be down here in the file, you can see A, you can be like, okay, I wonder what that looks like. You can just open that up. Now, there are, of course, other IDE tools that can do that as well. In fact, Visual Studio Code almost definitely has that, where you can just like click on a component. It doesn't look like that worked here. It just took me up to the import. But so it's really going to depend on your tools. And in cases like that, you should, if this is a team discussion, then you should definitely talk about standardizing your tools as a team, just because that makes it much easier for everybody to be on the same page and share tips as well, right? If everybody's using VS Code versus if one person's using VS Code, one person's using JetBrains, one person's using something else, then they're all going to be like, I don't know how to do that and that. I don't even know if you can. And the organization, the preferred organization, is going to change as a result. So anyway, that's just something I wanted to mention, but that's a very good question. So hopefully that answers it. Oh, and the other thing that I wanted to mention as well with regards to having a fairly flat folder structure is that it just makes it easier to import things, right? If you have a util folder and you have to you have to write out an entire file path where you get the horizontal scroll in order to import that, that's just not going to work in the long term. That's going to make everybody very frustrated, I think, in the long run. So anyway, hopefully that answers that question. So let's see here. All right, so let's move on now to the next topic that we were going to discuss, which is routing and navigation best practices. So the first thing that I want to mention here is that React Router as a whole has changed quite a bit over the past few years, and I'm not quite sure what the motivation for all those changes has been. I haven't actually looked into it that much. I've just learned the new way to do it, and that's about it. But that's something you should keep in mind. Is there's a lot of examples that you'll see, and my examples might even be guilty of this here. There's a lot of examples that you'll see that don't quite use the newest syntax for React Router, right? Like React Router is on version 6 right now, and if you take a look at version 5 or version 4, there is quite a difference. There can be quite a difference in how certain things are done with those. So anyway, the first thing that I want to do here is just kind of go over what we're going to be talking about here. We're going to start off by talking about just some of the best practices with React routes in general. Right? This is just going to be some general tips for organizing your routes, specifying them. Dynamic routing and lazy loaded routes. Really, lazy loading is the main thing I'm going to talk about here. Dynamic routing isn't really something that we need to talk about at this point. But lazy loading, very interesting thing, especially for larger applications. You can get a very big performance boost up front. And the last thing we're going to talk about is route guards and authentication flow and how that fits into React routing. So anyway, that's what we're going to do here. So the next I guess let's just go on to the next slide. So there we go. All right, so let's start off by talking about some general best practices, some general tips for working with React Router. This is definitely something that it's obviously a very important part of any multi-page application. Well, single-page application, but with pages that look like it's multi-page. Really, this is one of those things that becomes harder and harder to change as your application grows, right? As you start, especially after you implement something like an authentication flow, and as one page is linking to another, which is linking to another, it can become pretty difficult to get your app to behave correctly if you don't set up your routing correctly from the very beginning. So it's a pretty important thing to put a little bit of thought into, and well, hopefully some of these tips help you as well. So the first thing here, the first tip is that you should try and keep your route definitions centralized. This is I've definitely seen code bases that try and do different things here. So for example, one thing that I've seen before, which is a little bit interesting, is like a project might have a pages directory. Let's just try and write that out. Hopefully you can read that. There we go, pages. That's my mouse writing skills. So you might have a pages directory, and then you might have a file in there for each page. And what you could actually have is you could have each of those pages export some sort of information, right? Each of those files export some sort of information about what route that page wants to be on, so that we could just go through each of these files and kind of automatically generate those routes. So here's what this would look like. Let me actually go over to my IDE again, and I'm just going to create a new file in source. We'll just say something like, well, here actually, yeah, I'm just going to do a single example of this. So we'll say something like my page.js. And we might have some sort of page component in here. We'll just call it my page. It's obviously going to return some sort of JSX. I'll just ignore that part for now. But then one thing that you could do, which is not the recommendation here, but I have seen it done, and it's got a few, it's got some benefits to it, is you could actually have something like, we'll say export default, and then you could export the component, of course. So you could say my page. And in addition to that, you could say something like path, and you could say that you want this page to be displayed on /mypage, right? And then what you could do is you could actually have your app component or some other component or utility go through the entire directory that these pages are in. Remember that this would be a page inside of a pages directory, and it could just take the default. The default, what was I saying here? You can just take the default export of each of those files, look for the path, and automatically set up the routes for you. Right now, the beauty of that is that it would make your page, your page components very self-contained. You wouldn't have to, if you wanted to change the route of a page, you would just go to the file of the page, which perhaps makes a little bit more sense to most people than actually going to a separate router file in order to change the route of a page. But overall, this can just get very confusing because it makes it very hard to have a centralized map of your site. So that's why my recommendation isn't to do this, although it can be a fun thing to experiment around with. My recommendation is to have all of your routes kind of defined in one place, right? In one centralized place, so that, again, you can have a nice map of your site. It's sort of the same reason, sort of the same kind of motivation as what we were talking about earlier with what were we talking about earlier with what were we talking about earlier? Sorry, after I've been talking for 3.5 hours, it becomes a little bit difficult to keep my train of thought going. But no, it's a little bit similar to what we were talking about earlier with the feature-based code versus function-based code. When you have feature-based file structures, and you can immediately see all of the features in your files, of what your app can do, it makes it kind of much easier to understand, at least just at a glance, what your app can do. It acts as sort of a table of contents for your site. But when things are organized in a functional way, it doesn't quite do that so much. It's really a little bit more generic. Um, so that's kind of the same thing of keeping your routes centralized. That acts as sort of a backup, or that acts as a table of contents for the structure of your site, so to speak. All right. So the next thing here is to use human readable semantic URLs. And this is just a recommendation no matter what kind of site you're building, but especially for sites with SEO, mostly because if you're creating a blog site or something like that, and you're using a long randomly generated ID in that URL, it's just not going to look good, right? People, especially non-technical people, get a little bit put off when they see that you're going to a site. If someone posts a link to your article, let's say, and they see that you're going to a site that's like myblog.com/ and then it's just this random series of strings, people get a little bit unnerved by that, versus if you go to myblog.com/articles/ React best practices, let's say, people know exactly what to expect there, or at least they feel like they do, which is, just, it enhances the user experience. But besides that, going back to the previous bullet point, having these human readable semantic URLs makes it so that we excuse me, makes it so that it actually does act like a table of contents, right? Whereas if you just have URLs that don't really make a whole lot of sense, or that don't quite fit together, it's going to be a little bit confusing. And this goes also for doing nested paths, even if those, in React apps, those paths aren't actually nested, right? This is just kind of a leftover from when the URL path in the earlier days of the internet was actually just accessing HTML files and stuff like that. So by saying something like /path/ hello, right? Let's say this hints at the fact that the hello page, whatever that might be, is somehow related to the path page, right? It suggests that you probably get to the path page, it suggests that you probably get to the hello page by going to the path page. So things like that. I mean, it can really make it much easier to discern what the structure of your site is. And as a follow-up to that, using nested routes for hierarchical pages can be very useful as well, just because that again is going to really help you understand the flow of your site and what pages are related to which other pages, right? And how you get from one page to another. Okay, so anyway, protecting private routes. This one's kind of interesting because obviously in the front end, there are no truly private routes, unlike on the back end, because the user has a copy of all of your front end code. That's just kind of a fact that front end developers have to live with. But nevertheless, I mean, assuming that a lot of the people who are using your site are not technical people, this will just help them to have a better experience, right? Because if they try and go to a page that requires them to be authenticated in order to load that data, we're not going to want them to even see that page, because it's just going to display some sort of error message if they're not logged in. So by having private routes, we really can improve the user experience there, and just make sure that they don't end up somewhere that they're not supposed to be. There we go. Okay. So those are just some general best practices for working with React routers. If you want me to go into any of these in more detail, I definitely can. But let's just move on to the next one here, because this, I think, is personally the most exciting one. And this is the idea of lazy loading routes. So the basic idea of lazy loading routes is, the React apps that we create. Let's say that we have a React app and it has 10 pages in it, right? Well, while all 10 pages might not necessarily be displayed at the same time, I mean, in fact, they're almost never going to be displayed at the same time, they're still going to get loaded in that initial page load when we're loading our React bundle, right? When we're loading our React scripts. Those 9 other pages that you're not looking at right now are still getting loaded even though we're only looking at one page. So the basic question of lazy loading routes is, why should we load the entire site before the user can see anything? So again, with lazy loading, what we're allowed to do is we're actually allowed to say, hey, this component, I don't want to load that thing until I need it. And this reduces the initial load time because, well, we're only loading the exact components for the page that the user is going to be looking at. So that's again a very important potential improvement, potential performance improvement for our application, especially for larger applications, right? If your application has many pages with a lot of data on them, then you're probably going to want to look into this lazy loading thing in a lot more detail. So anyway, another interesting thing here is because we do have to load those pages at some point if we ever want to render them. So let's say that we have, I just need a new file here to type instead of having to write all this out. Let's say that we have a new file here, and I'm going to zoom in a little bit also. So let's say that we have a few pages. Maybe we have a home page. Maybe we have an about page. Maybe we have an articles page. Maybe we have a product page. And maybe we have a shopping cart page, okay? Well, when the user visits your site for the first time, they're probably going to go directly to the home page. Now, what this means is that you could lazy load everything but the home page. And I'm just going to put an L next to these just to indicate that. Right, you could lazy load all of these except for the home page, and that means that the only file that you're going to load in that initial load is going to be the home page component, right? The rest of these are not going to be loaded by default, at least not initially. However, chances are that the users are going to go from your home page to somewhere else in your application, right? Maybe they go from the home page, and from your data analytics team, you know that they usually go from the home page directly to the product page, and then they go to the shopping cart page, right? Maybe you know that users don't usually go to your about or articles pages, as is very often the case when companies try to add those to their site. So in that case, you have a few options. One option would be to obviously not lazy load the product page and shopping cart page, right? So that because we know that the user is pretty likely to go to all three of these pages, we might just want to have all three of those loaded at the same time as part of the initial load. But another option would be to actually lazy load the product and shopping cart page, but not until a little bit later, right? So what we can actually do is we can have the, we can only load the home page. We can have the rest of the pages be lazy loaded. But then what we can do is on the home page, when the user starts to hover over that little products button, right? If there's a button here that says something like shop, well, we can actually start loading that product page when the user's mouse hovers over this button. And that's a pretty cool possibility, right? Because from the user's point of view, it's going to look like we already had that loaded because we're getting that extra little bit of time. And I'm sure there's even other ways that you could, there's other methods that you could use to trigger actually loading this page. Maybe it's when the customer scrolls down to a certain point, or when the customer has spent enough time on your site, you know that chances are they're probably going to go to your product page. So you could even preload it then before they've even hovered over or clicked the button. So that's really where your analytics team is going to come into play. They're going to be really useful. They're going to be able to tell you what paths users usually take through your site, what they're going to tell you what kind of actions they usually do, what kind of indicators there are that a user is going to go to your product page or shopping cart page. And just using that same logic with the shopping cart page, maybe with the shopping cart page, we can wait to load that until the user has added one product to their product page, right? So what you can do is when the user adds a product, when they click add to cart or whatever, just going to try and write add there. Maybe at the same time, you could also load the shopping cart page, because now you might need it. Since they've added something to their cart, the chances are pretty good that they are probably going to want to chances are pretty good that they're probably going to want to look at their shopping cart at some point. All right, so that's the basic concept of lazy loading. Hopefully that makes sense so far. So what I'm going to do here is I'm going to show you the basics of how to do this. So what we're going to do is in our app component, and I'm just going to remove all of this old logic from our React rendering example, right, with A, B, C, etc. I'm going to remove all of that. And instead, what we're going to do is we're going to set up some routes, and we're going to try and implement that situation that I just mentioned before. So here's what this is going to look like. We're going to say, first of all, we'll want to create some pages. So let's just create a new folder in here called pages. And then what we're going to do is we're going to say new file. We'll create a homepage.js. We'll do another file. We'll call this aboutpage.js. Do another one. We'll call this articlespage.js. We'll do another one here. We'll call it products page. And we'll do one last file, which we'll call, what was the other one? Shopping cart page. That's it. Shopping cart page. And then we'll just go through and do a very simple implementation of all of these. We'll just say something like export default. And I am using export default here. Notice this is actually kind of important. I'm going to say export default homepage. And then I'm going to create that. So we'll say const home page equals. And then we don't need any props or anything. I'm just going to return some simple JSX that has an h1 tag saying home. And then we'll just do that same thing for our other pages. So I'm just going to copy this and paste it in all of them. And we'll go through and change those names, of course. So we'll change this to about page. Change this to about page. And we'll go to our articles page. So we'll change that to articles page. Change that to articles page as well. And then we'll do products page. We're going to change that to products page and products page. And last but not least, we're going to do shopping cart page. So this is going to change to shopping cart page. Cool. So shopping cart page and shopping cart page. Awesome. So, also, dang, I forgot. We need to change the titles here. We'll say about. We'll change this to articles. Oops, there we go. And we'll change this to products now. And then we'll change this to shopping cart. Awesome. So again, let's go back into our app component. And what we're going to do is we're going to define some routes for this. Now, an interesting option that's become available with routes in React Router lately, I think it might have become available in React Router version 5. I don't remember exactly when. But you used to just define your routes declaratively in React components, right? You used to say something like router, and then you'd have individual routes, and each of those routes had a path prop, and then you could define which component you wanted to be displayed inside of there. However, in more recent versions of React Router, what they actually allow you to do now is they allow you to specify all of your routes as an array of JavaScript objects. Now, your first question might be, why would you want to do that instead of specifying them as a series of React components? Well, the fact is that specifying your routes in an array of JavaScript objects gives you a lot of flexibility, and in general, it can also be a little bit more readable. So let me show you what this is going to look like here. First of all, what we're going to do is we're going to start off by importing something from React Router. Actually, we'll need to install React Router first. I forgot about that part. I'm going to say npm install React Router DOM. That's the page that we want to install there. And I believe we also need to install. Nope, actually, that's it. That's all we need to install. So we're going to install React Router DOM. And now that we've done that, the next thing that we're going to do is we're going to open up our app file. We're going to say import. And we're going to create something called create browser router. All right, that's kind of the same thing as importing the browser router component as well. And then what we're going to do is we're also going to import something called router provider. All right, we're going to import those from React Router DOM, of course. And here's what this is going to look like. We're going to create an array of JavaScript objects that represent each of the routes of our application, as well as the path and contents of that page. Now, you might have noticed that I'm starting to type out const routes up here at the top, but in fact, I think I'm changing my mind, because what I actually want to do is create a separate file that will act as sort of our centralized map, right? Centralized table of contents for all of the routes in our application. So what I'm going to do is I'm going to say new file. We'll call this routes.js. And then what I'm going to do is I'm going to say export default. And this is going to be the array of routes. So what this is going to look like is each of these route definitions is, as I said, just going to be a JavaScript object. And there's a number of different properties that we can add to it. So one of those is we can add a path property. And if we want this to be the home route, we can just say / and then, oops, I need to remove that equal sign after export default. And then we can specify the contents of this route by saying element. And if we want this to be the home page, we can say home page like so. And we will need to import the home page. So I'll say import home page from /pages/homepage. There we go. And then we can do basically the same thing with the rest of our pages. Now, again, what this does, in my opinion anyway, and certainly I think in the opinion of the React Router library, this is a little bit more readable than having all of our routes defined as React components. That's just, as much as React a little while ago anyway, I don't know if they're still pushing quite as hard for that, but as much as React was trying to make everything definable in a declarative way by making by using React components, as was the case with React Router components. The fact is that this is just a little bit easier to read than saying something like, route path equals / and then say something like element equals, and however you used to do it. I don't even remember how that used to work. Homepage, something like that. Right? This is just a little bit easier to read and easier to kind of parse through mentally than the old way of doing things, in my opinion, anyway. And actually, you can still do things that older way as well. This isn't the only way you can do things now. It's just a way that I wanted to show you because it matches some of the other recommendations that I made. All right, so hold on a minute. All right. So anyway, the next route that we might want to define, let's just go through and define routes for all of our pages, would be the about page. So we might have the path there be /about. The element here is definitely going to be the about page. There we go. So that's going to be automatically imported for me there. Let's see, what else do we have here? We'll want the articles page. So we'll just say path /articles. And then we'll say element. And this is going to be the articles page, of course. So there we go, articles page. And let's go through and create the last few. This is maybe a little bit tiresome, so I'll just copy and paste that a few times. There we go. Paste that there. There we go. And we need, we need one more of those. Just add that, paste it. There we go. Cool, so we have articles. Let's do, what else do we have? Products, so we'll say /products. That's going to be the products page, of course. We have shopping cart. And actually, that is the last one, so I didn't need this last one here. So let's trim those like so. And, oh, here, sorry, we need to, oh, we did have another one. That's what I did. That was a silly mistake there. So let's add those back. So this is going to be shopping dash cart, and then that's going to be shopping cart page. Let's try and get that imported for me automatically. So shopping cart page. And then we need our, oh, never mind. Oh, here, this should be products page. Sorry, I'm getting a little mixed up here. All right, so about, or we have home, about, articles, products, and shopping cart. That's all we need. Okay, so I didn't actually need this one. I was just getting confused by the typing mistakes that I had made. All right. Oh, and it looks like I missed a few of the imports here, so let's just add those. Say about page, articles page, from pages / articles page, and then for the products page, we need to import the products page from /pages / products page. Awesome. Cool. So now that we've done this, the next thing that we're going to do is, well, let's just test this out first of all, I guess. So let's go back to our app component. We need to just import these routes by saying import routes from /routes. And now we can use that create browser router function by saying const router equals create browser router. And we're going to pass our routes to that as an argument. And then we're going to use this router provider thing where we say router provider. Let's try that again. Router provider. And this is where we're going to have router equals router, like so. Okay, so this is pretty much all that we'll need to do right now, I believe. I believe that's all the setup we have to do. So let's just give this thing a try. We're going to run our application with npm start. And what we should see is that this will open up in a tab. All right, let's just give it a second there to start up. All right, and it doesn't look like it's displaying anything, so I think I didn't quite do this right. So just give me 1 second here. Okay, let's just take a look and inspect and see what's going on here. All right, so let's take a look at the elements. Doesn't look like there's anything in the root, so let's actually go back here and all right, hold on just 1 second here. All right, you know what? I need to, my notes were all wrong, so I need to just go back and fix those. So why don't we just take a quick 5-minute break here, and we'll come back to this shortly. So I'm just going to push out the 5-minute timer, and I will just get a final snack, final coffee refill, and when we come back, we'll finish this up and go back to any other topics that we wanted to cover. So I'm just going to push the 5-minute break timer out here, and I will see you all in 5 minutes. All right, so welcome back, everybody. I figured it out. I figured out what was going on like a moment or two after I did that break timer, but I figured I would give you the break anyway. Let me just share my screen again and see if you can see it because I was just so focused on it that I focused on the syntax of the uh, provider itself that I missed something very important, and that is I just forgot a return keyword. So that was a pretty epic fail. But anyway, now that we have that, we should be able to see all of our pages showing up. So yep, sure enough, if we go back, we see our home page. If we go to /articles, for example, we'll see our articles page. We can see our about page, etc. Um, and I guess here, in order to make this a little bit more obvious what's going on, we're also going to need to have some sort of link component in here that will allow us to go from one page to another without actually refreshing our page, which kind of eliminates any kind of demonstration here. So let's just do that by importing a React router DOM link component. And what we'll do is we'll just add a simple nav bar up here at the top of our app. Now, you would want to define this as your own, as a separate component. But for now, just to keep things moving here, we'll just put it inside our app component. So here's what this is going to look like. I'm just going to have a simple div, and I'll just have links to each of the different pages. So we'll have a home page link. So we'll say home. And then we'll do the same thing for our other 4 pages. So we'll have our about page. We'll have our articles page. Change that to about first. There we go. We'll have our articles page. We'll have, there we go, articles. And then we'll have our products page. So that should be /products. That will be products. And then we'll have shopping cart. And that will be shopping cart. Now, another interesting thing about this, too, that I'm realizing right now is that there is a little bit of duplication going on here with regards to the links to each of these pages, right? So you can see that we're defining the links for each of these pages in here, but we're also defining them in our routes.js file. So what you might want to do, and what you could do if you wanted to, is you could actually just use map and loop through all of these routes pages to create the basic nav bar. And that would mean that if you were to go through and, if you were to do something like change one of the paths for one of your pages, right? If we were to change about to something like about me, then you wouldn't have to change that in 2 places, right? That's just that's kind of a software architecture rule of thumb, is that every change ideally should only include changing one thing. In practice, that's pretty difficult to achieve, but that's just something I wanted to mention there. Cool. So anyway, hopefully this is making sense so far. So let's actually go back and see if those links work. All right, I'm just going to refresh it there. Oh, that's because I changed about me. Let's save this again. Go to home. Oh, actually, that's not called home. There we go. Just go home. Okay, something's not working there again. Let's inspect this and see what's going on. All right. Okay, so apparently, oh man, this React router just is not being kind to me. Let me just take a look here. Something real quick. Oh, that's because that needs to be inside the router provider. That's why. All right, so here's what we're going to do. We're going to move this router provider. I believe we need to move that up. So let's actually move this into our index.js file. All right, so we're just going to move this logic that we had here. I'm just going to copy this, move that into index.js. And now that we have that, we should be able to just have our provider thing here. So we'll just add that like so. Go. We'll paste that like so. Okay. So hopefully that fixes it. something that's a detail that I forgot about here. But anyway, there we go. All right, let's give this another try. And then, well, here, I guess that probably isn't going to work either. But let's just give this a try. All right. Okay, so nope, that didn't work either. So hold on just a minute here. I was trying to reorganize all of my example code on the fly, and it apparently just isn't working. So here's what we're going to do here. We're going to move those things back into here. And for now, this is going to be pretty bad, but I'm just going to put all of these links into the pages to see if that fixes it. Okay, there we go. I'm going to copy this, move these, and I'll put these into the home page. Let's just, we'll try that first to see if that works there. So there we go. We'll move that, and let's try now, just removing all of these links, and we're going to move the import link thing into our home page. So we'll add that there. We don't need those other imports. And now, if we go back to app.js, let's take a look at our, so we already have the router provider. Let's go back to index.js. We don't need that anymore. We can just remove that. We can remove these things as well. And we'll remove that. And there we go. Okay, so everything should be hopefully back to normal there. So sorry for the confusion about all of this. I was, again, trying to refactor all of my example code in my head here, and it just didn't quite fit the expectations here. So let's try this again and see if this works. All right, no, it doesn't like that. Oh, that's okay. That's for a different reason. So let's go back to our home page now, and we just need to obviously wrap those in some sort of fragment. So there we go. All right, let's try that again. And now, yay, we have the links, and we can go to the About page. We can go to the Articles page. We can go to the Products page, Shopping Cart page. There we go. Cool. So now that we have that set up, the next thing that we're going to want to do here is we're going to want to actually see how we can lazy load these pages. Because again, right now, when we load this React app, all of those pages are actually getting loaded. They're just there in the background, not being rendered, right? So what we can do here is, here, let's open up our inspector window and our network tab, because what you should see is that you'll actually see these pages being loaded when we, in the same way that when we hit refresh here and load the initial page, we see this bundle.js being loaded. We should see those individual pages being loaded as well when we go to these articles. But first, we obviously need to take a look at how we can say that we want to lazy load these pages in the first place. Well, all we need to do here is we need to, here, let me just make sure I've got my notes up here so that I know what to show you. Basically, the way that we do this is a very similar way to how we specify the element, but we basically make it very clear that we want the element to be loaded at a later time. So here's what this is going to look like. We're going to say path, and then we've got that, we've got the path we want our homepage to appear on. But then what we can do is we can say, instead of element, we're going to say lazy, and this is going to look like this. It's actually going to be a function that will be called when this, when we decide that we want to display that page. And in this case, we'd say equals import, and that's going to be ./projects. Okay, so that's how that works there. Basically, this import projects thing means that when we want to display that page, React is going to go take a look at the lazy thing. It's going to see that we want to import, or sorry, not projects. That is homepage. There we go. And that's actually going to be /pages/homepage. There we go. And that's going to tell React that we want to load that specific file only when we want to display this, only when we want to actually display this page. So for the home page, since we obviously want that to be the first page that people go to, that's not going to be quite as important. But for the for our other pages, that's definitely going to be important. So let's change these around to use lazy instead. And if we make this one look like this, we'll say lazy. That's going to be import, and this will be /pages/about page, and we'll no longer need to import that up at the top here. Well, what we should see if we, that should be a comma there. What we should see if we, I'm just going to restart the app. We shouldn't need to restart the app, but just in case I wanted to do that. But what we should see here is if we go to the home page, right? So we're just on the home page here. We'll open up the network tab again. If we go to the about page now, we're going to see that another chunk actually loads, right? This is the about page. This is the code for the about page that gets loaded there. Now, something that is something that you're going to notice here is that there's not actually an about page being displayed, and that's something that we'll come back to in a minute. But first, I want to point out that if we go to any of these other pages, that's not the case, right? We don't see the other pages being loaded because they've already been loaded from our, they've already been loaded from React. So anyway, the next thing that we're going to need to do, another thing that I wanted to show you actually is, here, if we go to our about page here, no, sorry, not that one. If we go to our, routes, that's what I wanted. Another thing that you can do with lazy loading is normally if you wanted to lazy load a page, that page is going to actually obviously be loaded first, but if that page needs some data, right, you're going to have to wait until that page is loaded and then renders and then loads its data from the server over here, right, in order to display all of that data. But what you can actually do in React Router 6 is you can specify some data loading that needs to happen at the same time. So what that looks like is we can say something like, what is it? We say loader, all right? And this is basically a function that gives you a request object that you can actually make a request to your server with. That's something that we'll talk about a little bit later. But anyway, let's take a look at this about page and why it's not rendering. So here, hold on just a minute here. I again just need to take a look at my notes because that wasn't something that happened to me when I was preparing for this course. So here, just give me a second. Here, let's try something a little bit different here. Looks like if we do this, we can say something like, here we'll say equals async, and then we can say something like constant about page equals import. And then what we can do is we can say return, and this is going to be an object specifying what the component should be for that route. So let's give that a try. Hopefully that one works now. And now if we hit refresh and go to the about page, oh, that was unexpected there. Expected a string or a class function, but got an object. Not sure why that happened. This React Router 6 here is giving me a lot of trouble here. So I'm sorry about this. I'm sorry that this demonstration isn't going quite as well as it was supposed to. So let's see here. All right, well, maybe what I'm going to do here is just move on to some of the other content because I don't know why this isn't working and I kind of don't want to just sit and troubleshoot this in front of all of you. So why don't we go back to another topic here? Oh, and actually, that's right. So one of you noticed it. That's just another dumb, here, where was it here? In our routes, there we go. I needed to say await. So someone mentioned that I forgot the await. That's, I think, why that's happening. So let's give this another try. And this will be great if this fixes it. Oops. Okay, yeah, that still didn't work for some reason. Okay, so here, let's try and go to that. Yeah, that's not working for some reason. All right, anyway, what we'll do is we'll just move on and go on to another topic. So let's go back to our, let's see what else we wanted to talk about. Route cards and authentication flow. I'm going to skip that one as well, just because it's doesn't seem to be behaving for me here, and my notes are clearly not what they needed to be for me to demonstrate those. So let's go back. What I want to do here is I actually want to talk about more of the topics with regards to component best practices in React. So what we're going to do here, let's talk about, I guess a good place to start here is function versus class components. All right. So function versus class components. This is something that this is a kind of a debate that's been going back and forth for a while, ever since function components were given the same abilities through React hooks as class components, right? It used to be that function components could only be used when you didn't need any kind of internal state. But now that's not true, obviously, because we have hooks. So with class components, obviously these components use ES6 classes, and the way that they allow us to handle the state and lifecycle methods is by is through specific methods that they give us, right? So, when the component is rendered, there's one method that will be called. So if we want any code to be called when a component is being rendered specifically, we can just put it in that method, right? So a lot of people like that. Because even though it's more verbose, right? Even though it's a little bit more difficult to, it takes a little bit longer to write out a new component, the structure is very clear, right? So the difficult part about that, though, is, of course, that class components can tend to get a little bit tangled. Their state. I thought that the next bullet point there was going to be something about that. But their state can get a little bit difficult to manage when it gets complex enough, right? And especially when you're when you're working on a fairly complex component, it can become very difficult to really know or to really figure out what a class component is doing and when each of its little, when each of its pieces is going to be called. So that's something to, that's something to keep in mind when thinking about using class components. But one benefit of class components over function components, and I used to have a different opinion on this, but my opinion has changed over a little while because I've seen the same thing happen, is that when let's say that you're bringing someone onto your React development team and they're coming from an object-oriented background, right? Maybe they're used to working with Java. Well, function components are going to be very, very hard generally for them to figure out, right? So that's one thing to keep in mind is if you have, if you know that your team is going to have a lot of object-oriented developers on the team, it might be worth just doing class components instead, just so that they're not unnerved by the functional components, right? Because just in my experience, object-oriented developers are they really kind of freak out when they see all of the React hooks and stuff like that, and they don't really know what's going on. So that's just my experience. It might not be your experience, but anyway, moving on to functional components, basically all that these things are is they are just they're just plain old JS functions that take some arguments. Normally that's in the form of just a single object with properties called props, and those basically for hooks, using for state and life cycle, we need to use React hooks because up until hooks, there was really no way to add those to function components, and we really just used function components for for displaying regular super dumb components. All right. Just a minute here. All right, so that's the first thing to know about function components. And in general, function components, as long as they're fairly straightforward, are recognized as being simpler and more readable, right? You don't really need to know too much about the component lifecycle in order to get the basic gist of what's happening in a functional component, right? You can just kind of look at the JSX that it produces, and that's really all that you need there. So the other thing, though, is that function components are just generally recommended for most cases. In other words, function components should probably be the default component that you choose whenever you're starting to build out pieces of a React project. And only when you find that things are getting more complex should you consider switching to class components. And really the verdict here, the general verdict, and this again is different from what I used to think, because I used to want to use function components for everything. But the general recommendation that I would give is that for complex lifecycle needs, right, where there's things that you just need to happen at specific points in the component's lifecycle, it can actually really improve readability quite a bit when it can really improve things quite a bit when you do, when you use, sorry, I'm losing my articulation here. It can really improve things quite a bit when you're using classes, because, again, they have specific methods in a specific place to put everything. Whereas even though function components allow you to tap into all of those life cycles, they allow you to do pretty much everything that a class component can do. When you start doing really complex lifecycle needs in a function component, it can just get a little bit difficult to keep track of. That's been my experience anyway. But that's something to keep in mind. So anyway, that's function versus class components. If you want me to go into detail on that a little more, you can feel free to do so. But I'm going to move on to the next one, which is using composition instead of inheritance. So using composition instead of inheritance, this is something that's recommended by the React core team, because what people will tend to do is they'll tend to use what object-oriented programmers, that is, will tend to try and do in React, is they'll try and bring inheritance into React. And just to compare inheritance and composition, it's a very subtle difference, but it's definitely something that is worth noting the difference between. And that is that inheritance is when you say that A is a something, right? So you could say that a car is a vehicle, or a cat is an animal, or a programmer is a human. Whereas with composition, we say that A has a B, right? So you might say that a car has an engine, instead of trying to extend an engine class to create a car, right? And the beauty of composition is that it allows you to take lots of smaller pieces and put them together into one cohesive whole. Whereas inheritance, even multiple inheritance, runs into quite a few problems when you try and do that, right? So for example, if you had, let me think of an example here, right? If you had an engine class and you also had a wheels class, right? If you were to try and inherit from both of those to create a car class, because they do share a lot of behaviors, both engines and cars start up, and cars obviously roll as wheels do. You could try and do that, but ultimately it's just not going to be very flexible, and it makes a lot more sense to think in terms of composition in that case. So that's generally what's recommended by React. So just a few additional things about composition. Composition tends to simplify maintenance, and inheritance tends to make maintenance much more difficult in React, right? So React is not the kind of application or the kind of library where you should be creating these complex inheritance hierarchies. You should really be using composition for most cases. And another very important part of composition is that it supports customization without altering the internals of the component. So for example, if we wanted to, let's see here. All right, so going back to our old example of like trying to create a car class from inheriting from an engine class and a wheels class, um, if we wanted to change some behavior about how the car starts up, let's say, right? Let's say that we want the car to have an electric engine instead of a gasoline engine. Well, in that case, we would have to change the engine class altogether to make it a different type of thing, right? We'd have to change the behavior of the gasoline engine class. Whereas with composition, all we would do is we would say that instead of a gasoline engine, our car class now has a electric engine. So we'd be able to just create a whole new class and use that as a property instead of inheriting from it. So anyway, hopefully that makes sense there. Many of you may not be familiar with those inheritance concepts, but that's the basic idea, is that we can customize our components just based on the things we choose to compose from without actually altering those things that we're composing from. So anyway, that's we'll go into more detail on this later, but again, I just want to point out that this aligns with React's design philosophy for component reuse. They really do recommend that you use composition instead of inheritance for most cases. All right, so let's go back here, and I'm going to just show you a simple example of composition versus inheritance. First of all, the inheritance example, you should probably not write code like this. I really wouldn't recommend you do that, but I'm going to write a new folder here, which we'll call inheritance versus composition. There we go. And now we're going to have a new file here, and what this will look like is we're going to say, we'll call this inheritance, all right? So it's going to call this inheritance.js. And now that we have that, what we're going to do is we're going to add, we're just going to create a simple component. And what this is going to do is we're going to say something like, let's create a very simple, we'll do a button component, all right? So we'll say class button equals, or not equals, sorry, and this is just going to extend the React component. So we'll just say import React from React. We're going to say extends React.component. Okay? Cool. And then in this render method of this button, what we'll do is we'll say something like return, and then we'll just have this button here, and we'll say I am a button. Cool. So let's say that somewhere down the line and throughout our application, we want to display buttons of, I don't know, let's say we want to display buttons with different colors. Well, what that could look like if we were going to use the inheritance route, and again, I don't recommend that you do this, what that could look like is you could simply have this class, you could simply give this class a color attribute, right? So you could have a constructor here, something like that. Super, we'll say super. Sorry, that's not it. So we'll say constructor, and then we'll just call super. And then what we'll do is we'll have all right, sorry, I just had to make sure I was going in the right direction with this example here. But then we can say something like this dot color equals, and maybe we want to set it to, maybe we want the background color to be gray by default. Okay, well, what we could do in that case is we could create another class now that, sorry, hold on. We could create another class now that maybe we want it to be a red button, and we could have that class override this color in order to get another, in order to have that be another color, right? So here's what that might look like, and here, this is just kind of a silly example here, but we're going to say class, we'll call this red button, extends, and if we have it extend that button, well, what we can do is we can just say constructor, and we would obviously call the super constructor in there, and then we would say this dot color equals red. All right, and then what we could do is we could just have this render method have something like, you could basically set the color of that button in here, so you could add some inline styles, and by doing this in the red button, that would make that button red. again, stupid example, but you'd be surprised how many people try and do something like this with inheritance in React, where they actually try and inherit something from something else just to duplicate that behavior. So a simpler way to do this using composition would look like this. We could just say, I'm going to call this file composition.js. We could just say something like, let's see here. We could just say something like const, and I'm going to just use functions here, but you could do the same thing with classes, of course. Button equals, and then what we could do is we could just add a color prop to that button, and then we could say something like return button, and then we would have the inline styles there, and we would say I am a button. And then in order to create in order to use composition for this, we would just say const button, or const red button rather, and we could say, this one wouldn't even need any props, we would just say return, then we would use that old button class with color set to red. All right, so really those are two different ways that you can do the same basic thing, and composition ultimately is just a lot easier and leads to a lot more code reuse than inheritance does in React. So again, just the moral of the story here is to use composition instead of inheritance. Cool, so let's move on here. Let's talk about prop types and default props very briefly. So prop types, using these is definitely going to be a best practice, because even though we've added in, even though a lot more React developers are starting to use TypeScript, and TypeScript provides similar coverage for React, the fact is that there's just a lot of projects where that's not feasible, right? Where it's not feasible to convert everything into TypeScript. And frankly, a lot of people just don't really like using TypeScript in the first place, right? A lot of people prefer the flexibility that JavaScript provides with its typing system. But whatever the case with that, prop types are important because they actually do add a little bit of type safety to our components in our React projects. And by this, I mean that if we have a component that's supposed to take, let's say, an array, and we pass a number to it as that prop, well, that could potentially cause our application to crash, and that's never good for the user experience when that happens, right? So anyway, that's something to keep in mind there for sure. Hold on a minute. Just getting a sip of tea there. So anyway, it enforces a little bit of type safety, and it allows you to catch bugs before you release your application, or even before you do like manual testing on it. So that's a definite benefit to prop types. Another thing is that it enhances the documentation and readability for your components. And you'll see that even in many IDEs, they'll actually be able to pick up on prop types if you have some sort of React plugin installed. And when you go to use another component, let's say when you go to use a specific component with prop types in another component, you can actually see what those prop types are supposed to be and make sure that those are lining up. All right, so prop types, another thing about them is that they're a development tool only, so there's actually no production performance penalty, right? So these things aren't going to slow down your application in production because they're not included in production, right? Same as TypeScript. Even though the TypeScript types are in the code, we actually transpile those and create our production code from that. So our TypeScript is actually running there in the background. All right, so that's prop types. Default props. This is actually something that's kind of on its. I don't want to say it's on its way out. There was a little bit of talk for a while of default props becoming deprecated. But still, the idea of having default props, not just the idea of having default values for the props in our components versus having default props. I'll show you how to use these in a minute too, by the way. That's kind of a confusing sentence that I'm trying to formulate. But basically, default props give you the ability to ensure consistent behavior when you don't quite know what components are going to be calling your component, are using your component, right? So in other words, if you're creating, let's say you're creating a basic user interface component library, well, having default props on those components is, that might be very helpful because it'll prevent your component from crashing whatever the code is that's using it if they pass the wrong type of data by accident. So that's something that that you can definitely think about is default props. Definitely consider adding those to your components. And well, that seems to be the end of the component-related code. So if you have any questions about this, feel free to submit that to the Q&A widget. And I can always demonstrate some of these things for you. Otherwise, we'll move on to some of the other content that that we had here. So I'll just give you a few seconds there to submit any questions if you have them. All right, so let's see if, all right, so there's not too many questions here, but one question, which actually will work well with the content that I wanted to go on to here is, how can we protect React apps against cross-site scripting and SQL injection? Is content security policy enough to protect against XSS, cross-site scripting? So I actually have a series of slides on that, and I can just go through them. I suppose I'll just do that now. I don't see too many other questions coming through here that are relevant to the content at hand. But anyway, the thing to keep in mind with cross-site scripting in React, actually, I have a whole slide with this. So I hopefully you got what you wished for with that question. So protecting against cross-site scripting. First of all, cross-site scripting, what that is just to give you a general example here, what you can do, that's kind of a dangerous thing in really any front-end application. I'm just going to create a new file here. You know what? I'm just going to open this up as an example. There we go. All right, so let's say that we were going to, let's say that we're writing a very simple program whose job is to take data and create HTML, sort of like React, but let's just say that this is even simpler. So what we're going to do here is we're going to say something like const, and then what we'll do is, let's say that we wanted to create a simple function for taking a user's name, perhaps, and inserting it into a piece of HTML, like an H1 tag. Well, what that might look like is we might say, and actually I'll just use function here. We'll say something like insert name, and maybe what this does is it takes the person's name and it returns a string with that name inserted. So we might use backticks here and just say H1 name, and then H1. Close that tag off. Well, at first glance, this looks pretty innocent, right? But actually, this is a horrible, horrible sin that you can commit when writing any kind of front-end code, is allowing the user to specify anything that gets inserted and interpreted as HTML. You want to be very, very careful of that, because what the user could do here is they could insert, or they could set their name, right? What if we said const name equals, and then we wrote some script tags that said something like alert hacked. Oops, there we go. Alert hacked. And then script. Just close that tag like that. Well, once this gets inserted into the H1 headings, here's what that's going to look like. I'm just going to copy and paste it so you can see. And oh no, if we generated HTML like this and sent that back to the client, the browser would actually execute this, and it would actually display that alert in the user's browser. And obviously, this is a pretty harmless hack, but some other things that could be done would be things like displaying an alert asking for the user's username and password. That's been a pretty common thing there. You could also inject more HTML into the page that looks like something like a checkout form in order to get the user's payment information. There's just lots of stuff that hackers can do once they're allowed to execute arbitrary code in your React app. Now, in general, cross-site scripting isn't a huge concern in React applications because it's actually very difficult to insert strings like this one into React without them being escaped, right? So React escapes things by default, which means that if we were to, let's just use our, let's see what we have here. Let's just use our app component as an example here. If we were to have something like h1 in here, and then we'll insert the value of name, right? If we were to say something like constant name, and I'll just use that same example here. We'll say something like h1, and then close that off. Or actually, not h1. I want to do script. Right? So we'll say script, and then we'll say /script, and then we'll say alert hacked. Well, if we insert that name into our application here, it's going to be escaped, and so it's not going to actually be interpreted as HTML. So if we run this application again, what we should see is if we just go to our app component, let's just go to the home route there, since our about route is working. Sure enough, we see that this is just displayed as text and it isn't actually getting executed. However, if you were to do something, there is a prop that you can actually do, and I believe that it's called, what is it called? I don't even use it very much anymore, or at all. I think it's called dangerously set inner HTML or something like that. Let me actually look that up. So React dangerously set inner HTML. Yes, okay, so I did have that right. So if we have h1 and we say dangerously set inner HTML, they purposely make that a pretty long thing to, pretty long prop to use. You can actually set that to something like this. So you could say something like, you could actually insert that string into there. And I'm not sure if this is going to work here for now, but actually I'm trying to look at the exact syntax for doing this because, again, I never use this thing. I think it's something like this. I think you have to say underscore HTML, and then you can say something like name, perhaps. So let's give that a try. I'm curious if that will actually work. But let's just refresh this. And it doesn't look like it's actually running it. But if we take a look at our elements here inside root, we'll actually see that that script was inserted. So there's other ways that you could do this, and I'm sure that there's a way that you could get that to actually execute that. But that's the basic idea around cross-site scripting, is you want to avoid doing things like that. And React usually does a pretty good job of preventing that, just because it automatically escapes the values that you insert into your application. Right? That's just automatic in React as it really has to be, because otherwise we would have to manually escape everything in React. Cool. So anyway, hopefully that gives you the basic idea of protecting against cross-site scripting. Let's just see. I just had a few more bullet points on here. Stealing user credentials, stealing personal information. Another interesting thing that you could potentially do with cross-site scripting would be running things like crypto miners in users' browsers, or using their browsers to launch some kind of distributed denial of service attack against some other website. That's just fun stuff that other people can do, fun stuff that hackers can do when they get access to running arbitrary code on your front end. And another thing here is just to basically never trust user-defined values, right? I mean, you can trust them when you know they're going to be escaped. And again, React makes that it really does that by default. But, going back to the thing of like SQL injection, that's something that you're really going to need to watch out for on the back end, because really users can do whatever they want on the front end since they have a copy of your code. So anyway, the last thing here that I wanted to say is that another thing that you should watch out for is watching out for third-party libraries, because um, when you're using a library, you're using code that someone else wrote. So you should really make sure that that is a trustworthy library and doesn't have any major security vulnerabilities in it. So that's just something to keep in mind as well. Um, anyway, those are the main things I wanted to talk about with cross-site scripting. So the last thing, I have another question that says that a quick demo of custom hooks would be nice before we go. So I'm going to do that, and then that should be all for this course. So let's let me just head over to my IDE. All right, so going back to the idea of custom hooks. Let me just open up here we go. We had smart versus dumb, and then we had our user info and user profile page. The basic idea of custom hooks is that the entire process of state management and doing things like loading data, or really any other React hooks that we can insert into a function component, can actually be pulled out into their own separate function and created as a hook. Now, what I'm going to do, I suppose, is I'll just create a custom hook for this user profile page with loading this user data. And here's what that looks like. The first thing that you need to know is that custom hooks their name must start with use, right? So we have use state, we have use effect, we have use callback, we have use memo. There's lots of other things there, but the reason for that is that that's how React detects the hooks that you put in your components and make sure that they're used correctly. So what we're going to do here is I'm just going to say something like, we'll call this use user.js. And really, again, these hooks, these custom hooks are just functions, but they're functions that use other React hooks. So what this one could look like is we could say const use user equals, and what this would do, maybe this even takes the user ID that we want to load as an argument. And then inside here, we would use those use state and use effect hooks. And then we'll say import those from React. And we could basically do everything that we were doing inside the user profile page, but inside here. So we can obviously set up a user state. So we can say const user and set user equals use state. And then the initial value for that's going to be null, or whatever you want it to be. You can set it as an empty object. And then we could say use effect, and we could actually take care of loading all of that. Again, I'm just going to put a comment here saying something like load user data from the server. And under that, you can say set user, and you can set it to something like name. I'm just going to say show, right? And the cool thing here now is that now that we have this user state, we can actually make that available to a component that wants to use this hook just by returning that from this. So we can say return, and if we only want the component to have access to the user that we loaded, we could just say return user. And if we go back to our user profile page now, what we can do is we can just import that. I deleted too much there. We could say now const user equals, and then let's just import that use user hook. So we'll say import use user from /use user. And now we can say user equals use user, and then we can pass whatever ID we want to load the user for. And that's going to give us pretty much the same functionality with a much cleaner component, right? Now, another key thing about these custom hooks is that they really give you the ability to control what data you expose to the component. So for this use user hook, we could expose this set user function as well, just by returning that as an array, right? So we could say return user and set user. And if we go back to user profile page now, we could actually get both of those things here. And if we needed to change user later on, we could do so, right? So if we needed to maybe change that in set friend request, we could say set user and set that to some other value. But in general, you really want to put a lot of thought into what data you're exposing to the components, because they usually will use it if they have the ability to do so. Right? So another thing that you could do too, by the way, is you could actually, you could You can change the format here. So if you wanted to return this as an object, maybe have set user, that would force the components to actually destructure those as an object. So you can say user and set user. If you wanted to maybe make it easier to track the names of these pieces of data going through your program. So there's really a lot that you can do. There's a lot of choice that you have with regards to these custom hooks. And really you can use any hooks, any React hooks that you want inside of here. And you don't even need to use hooks either, right? If you really want to, you can just say something like, if you wanted to say something like const use send friend request, for example, right? And the only purpose of this was to return some function, right? You could say something like return, and maybe you have that send friend request inside of here. The reason that you'd want to do this, I'm not going to go into it right now, but it's because it would actually make this function, the send friend request function, a constant reference instead of defining a new anonymous function each time. But then you can just say return, and you can say send friend request. And oops, there we go. And that would allow the component to just have access to that function, right? So custom hooks, there's a lot of different possibilities with them, but in general, just from a simple, from a much simpler standpoint, they're usually used to just get all of the side effects, state management logic out of your components so that they can be much cleaner. That's really the main purpose of these custom hooks that you'll create, because really all that they do is combine the basic hooks that React provides you with anyway. All right, so I'm just going to say export default use user here just to make that code complete. And that is pretty much that brings us pretty much to the end of our course. So the last thing that I'm going to do here is I'm just going to push some of this example code up to GitHub for you. Perhaps you can figure out some of the things that didn't work. And actually, I was trying to read about the lazy loading in React Router DOM. Basically, I think it looks like there's just another mode or another syntax that I wasn't using, and that's why the lazy thing wasn't working. But all of the syntax that I showed you should be correct, more or less. So here, just bear with me for a second, and I will push all of this up to GitHub. So I'll say git add, git commit, I'll say end of course, and let me just create a new repo for this here that I can send you the link for. So we'll say repository name. We'll call this something like React Best Practices Code. I'm going to create this repo, and I will send you the, let me just push this up real quick, copy that, paste it, and push that up to GitHub. And there you go, you should have access to it. So this contains all of the code that I wrote. I'm just going to put that in the attendee chat there. There we go. Paste that. So you should be able to see all of this code. And again, some of it didn't work. So if you can figure out how to fix it, that'd be amazing. Feel free to open up a PR on that repo as well, and I will I'll take a look at it to see. But anyway, thank you so much for joining me in this course. I hope that you learned a lot here. If you have any questions, please feel free to reach out to me. And if you're interested in attending any of my other courses, I do have 2 more courses coming up this week. I'm not sure if there's still time to sign up for those, but they're on ChatGPT. There's something, prompt engineering for ChatGPT, I think, is one of them. And the other one is, I don't remember. I'm going to have to look at my calendar for that. But anyway, just take a look at those. If you search my name on the live training schedule, you can usually find those pretty easy. And well, that's about it for today. So thank you once again for joining me, and you can take us away, Andrew.
Okay, great. That does conclude the presentation. So thanks everyone for joining. One note I would add regarding Sean's future classes this week, registration should be open for those 2. Up until just shortly before the start of the event. So feel free to take a look for those on the O'Reilly Live Training platform. The only reason you might not be able to register is if we have a full session. We do have a max number of registrants we can have. So, if you're interested in those topics, take a look and you might be able to find the spot. But otherwise, last couple things I'd like to add before we wrap up. A reminder again that there will be a recording. That recording should post in about 24 to 48 hours. You should get an email notification when it does post, but the recording itself is going to be through your online learning account. So if you need a refresher on any portion of the presentation, you can always find it there. Also, last chance, we do have the course feedback survey. You can access that through the widget tray at the bottom of your screen. Any feedback at all you might have, we appreciate it. It just helps us improve these sessions over time. But with that, thanks again for joining. You can log off whenever you're ready. And we hope to see everybody back for another course soon. Have a nice day.